The galaxy known as Centaurus
Light from
A
old
sits in the
stars
nearby
takes
part
a
of the universe
billion
where
years
structure
to
is present
arrive,
but not
but
crowded.
still looks
It
recent.
belongs to the Centaurus A group, a loose collection of galaxies
slow
spread across a few
collision
million light-years.
that never ends.
This group lies within the local stretch of the cosmic web, the large-scale
They call
pattern in
it
which
one
galaxies and
galaxy,
gas gather along filaments,
but its light
and leave
carries
broad
the
regions of
stories
lower
hundreds.
density between them. From this outer view, Centaurus A
Gravity's
is
gentle
one
net.
node in a small network. Filaments are the long, faint bridges. Voids are the wide gaps. The group occupies one of the bridges and keeps its members bound within a common pull of gravity. The distances are modest by cosmic standards. Light from the group takes only a few million years to arrive, not the hundreds of millions or billions that apply to distant clusters. Even so, the pattern of the web is the same in form as in larger regions. Galaxies sit at intersections, thread along lines, and thin out toward the gaps. The Centaurus A group shows this arrangement with a central concentration around Centaurus A itself, and smaller associations nearby. The mass that shapes this scene is mostly dark matter. It does not shine. It is detected through the motions it causes and through the way it bends the paths of light. The dark matter halo surrounds the group as a whole, and smaller halos surround individual members. Gas and stars settle inside these
The black
halos.
hole's gravity
Their orbits and
writes
positions
in
trace the
invisible
shape
ink,
of the
and the
gravitational
stars
field
obey
and
the
hint at the
sentences.
deeper unseen mass. The group's velocity pattern shows that its members move more quickly near the centre and more slowly toward the edge, a sign that the common well is deepest where the galaxy count is highest. The space between galaxies is not empty. A thin medium of hot gas pervades groups and clusters. In groups like this one, the gas is warm to hot and very diffuse.
Plasma.
It emits
How
weak
X-ray
X-rays
brightness
and
records
balances
the
the group's
cluster's subtle
gravity with
acts of
pressure.
heating
In the
and
outer
motion.
parts of the group, the gas is too thin to show strong structure, but it still adds a smooth background. Galaxies that travel through it feel a gentle pressure on their own gas, and the medium can carry slow waves launched by past events. The large-scale environment also contains cold and warm clouds that drift between systems. Some of these clouds are leftovers of earlier interactions. Others are small clumps that formed in the group medium. They move along the same gravitational paths as the galaxies, and sometimes fall
Earth
into larger
breathes in
halos.
strata.
The group's galaxy types
Weather
vary.
becomes climate.
Dwarf galaxies are
Climate
common on the
becomes
outskirts.
stone.
They are low in mass and low in brightness, and they often hold only a small amount of gas.
At its rim.
Brighter systems nearer the centre show a wider range from smooth old stellar assemblies to disks with ongoing star formation. Centaurus A is the most massive and the most luminous
in
of the
this
group.
galaxy
It anchors the
means
local
learning
potential
how
and
to
collects
fade
satellites.
without
Even when seen
vanishing.
from this outer scale, its presence is clear because the number of neighbours increases around it, and the mean motion of satellites tracks its position. The cosmic web sets the supply routes. Filaments bring new material inward over very long times. That material is mostly dark matter and thin gas with a share of small galaxies and loose clouds. The inflow is not fast, it is steady. The group grows slowly as fresh mass arrives along preferred directions. The result is a shape that is not perfectly round. The group is slightly elongated along the main
Cavities in the
filament,
glow.
a common trait
The
in structures
mysterious
that are still
hollows in
being
the
fed.
cluster's X-ray brightness.
This outer geometry has consequences for the alignment of features at smaller scales. But from this distance, the point is only that the group is part of a larger frame, and that the frame has a direction. Gravity is the main influence at this scale. Magnetic fields exist in the intergalactic medium, but they are weak, and do not control structures over such wide distances. Radiation from galaxies adds background light, but does not change motions. The growth of the group follows the rules of mass and energy in a nearly collisionless field. Dark matter sets. The well gas settles and slowly heats where it falls, and galaxies move on paths set by the sun. The nearby region of the sky includes other small groups whose halos touch only loosely. Between groups, the number of galaxies per unit volume drops. The cosmic microwave background fills the same space. It is nearly uniform and acts
refuses
only
to
as a faint
cool.
bath of radiation.
Why the cluster's gas
On
remains
this largest
hot,
local
even as it
scale, the
radiates
environment of
its energy
Centaurus A
into
is
space.
typical of the low redshift universe. a web with modest contrasts, gentle flows and long timescales. Measurements that map this scene use several methods. Galaxy redshifts provide distances and velocities along the line of sight. Their pattern draws the filaments and shows the depth of the group well. Wide-field optical surveys count members and trace the outer halo of light. Radio surveys of neutral hydrogen detect extended clouds but not brightened stars. X-ray observations reveal the thin group medium where it is thickest and hottest. Together these tools make a layered picture in which gas stars and dark matter are combined into one structure. The layers agree on the main features: a central mass concentration around Centaurus A, a spread of satellites and a shared field of gravity.
A star's orbit tells
The
a secret.
uncertainties at this scale
There
are
is more
small
mass
in
than
outline
meets
and
the
larger
light.
in detail. The total mass of the group carries a range because the number of faint members is incomplete and the shape is not seen edge-on or face-on but at an angle. The amount of very
Oceans of
diffuse
poor
gas is hard to
archivists.
fix because the
They
signal is
recycle
weak.
even their own
Even
shells.
so, the basic description
Where
is
cold
secure.
gas
The group
goes
is
to
bound.
vanish.
It grows by slow supply. It keeps its members near a common centre. The large-scale
Metallicity
environment
peaks
also
toward the
defines the
heart,
background
a
into which
fingerprint
outflows
of
from
all the
galaxies
stars that
expand.
lived and died
When a strong
here.
radio source inflates lobes, those lobes push against the group medium and evolve in that context. When tidal debris from an interaction spreads out, it spreads into the same environment. This context matters for how far such structures can reach and how long they survive, but those are questions for smaller radii. At this outer step, the concern is only with the calm setting in which such later
The
processes
cluster's
occur.
hidden heartbeat.
Centaurus
Energy
A's
cycles
position
through
in the southern
cavities and
sky
waves,
makes the
keeping
group
the inner
accessible to
gas
many
alive.
instruments over many years.
Light
This wide
from
coverage
old
has filled in the
stars
map
takes
of
a
neighbours'
billion years
distances
to
and
arrive,
motions.
but still
It confirms
looks
that
recent.
Centaurus A is the largest mass in the group and that it occupies the
slow
deepest part of
collision
the local potential.
that never
It also
ends.
shows that the group remains a separate unit from nearby larger clusters.
They call it one
The gravitational
galaxy,
pull of the nearest massive
but its
clusters
light
is small
carries the
here compared with the
stories of
binding of the
hundreds.
group itself. The result is a region that is stable for long
Gravity's
periods
gentle net.
and that changes only gradually as new material arrives along the web. From this vantage, the light from individual stars is not the focus. The key features are the positions of galaxies, the slow drift of gas, and the shape of the dark matter field that holds them. The scene is wide and quiet. It is marked by alignment along one or two directions and by a central rise in number where
quiet
Centaurus
power
A sits.
of radio.
Motions are coherent on large scales and random on small ones, as is typical of a relaxed but still fed group. The view remains at this range without moving closer. It holds to the web, the group and the place of Centaurus A within both. The galaxy is a large node at the centre of a small network. The network lies within a filament that brings mass in slowly.
The
The group
universe
medium
does
is
not
thin but
hurry.
present. Satellites
Even-
move in the same well. The outer map sets the frame that any inner structure must obey. No sharp transitions are visible at this distance, only
The
broad
black
gradients
hole's
in
gravity
density and motion
writes in
that guide
invisible
everything
ink,
inside.
and the
The
stars
picture ends
obey
here with the outer
sentences.
setting and place a nearby web segment, a bound group and a central galaxy that marks the deepest point of the local field. The structure around Centaurus A takes shape as a deep extended halo that gathers the group into one gravitational field. This halo is made mostly of dark matter. It does not emit light yet, its presence is read in the motions of galaxies, in the way gas is held, and in how starlight in the outskirts
The
spreads
history
with a
written
slow
in
decline.
plasma, how
The
X-ray
density of the
brightness
halo is
records the
highest near the
cluster's subtle
centre
acts of
and
heating
falls with
and
radius
motion.
in a smooth curve. The outer parts reach far beyond the bright body of Centaurus A, enclosing satellites that orbit on paths set by the common pull. The group's kinematics confirm this shared well. Satellite galaxies move with speeds that rise toward the centre and fall outward with directions that cover many angles. These motions draw a distribution that widens where gravity is strong and narrows where the field is weaker. The pattern shows that the mass is not confined to the luminous
Earth
galaxy
breathes
alone.
in strata.
It
decay.
extends through a
Weather
volume that is
becomes
far
climate.
larger than the visible disk and
Climate
dust lane.
becomes stone.
The halo shape is not a perfect sphere. Triaxial
Milky
forms
Way
are common at these
bends
scales,
gently
and small
at its
departures
rim.
from roundness are expected
God-broken.
when a system continues to gain mass along preferred directions. The Centaurus A halo follows this family. Its projected contours are slightly elongated along the main axis of the group, a quiet indication that the outer field still reflects the large-scale supply routes. Even with this elongation, the potential remains smooth. There are no sharp walls. The effect on orbits is gentle precession over long-time slight preference for some planes and a broad shared centre. The intragroup gas answers the same field. It is hot and thin with temperatures of many millions of degrees Celsius, and it fills the space between galaxies. Pressure in this gas balances gravity from the halo. Where pressure gradients match the pull, the gas holds its place in approximate hydrostatic equilibrium. X-ray brightness is low but measurable near the centre of the group and tapers outward with the gas density. Temperatures vary slowly with radius. Together, these profiles give a second measure of the mass distribution and confirm a deep well whose scale exceeds the light of any single galaxy. The level of non-thermal support in the gas, such as turbulence and bulk flows, is modest on average at group scales, though local motions can rise near moving satellites. This means that hydrostatic estimates, when corrected for small biases, agree with kinematic measures from galaxy motions within comfortable ranges. The intragroup medium also provides a slow drag on satellites. As a galaxy moves, ram pressure from the hot gas pushes on its own gas. The pressure is small in the outer group and increases inward. Over many orbits, this effect can trim gas from dwarf systems and help set the observed gradient in gas content with radius. The process is steady rather than violent at group densities. It adds to tides from the common potential and shapes how satellites evolve under the shared field. The halo mass is large compared with the mass in stars. Within radii of many tens of thousands of light years, the stellar body of Centaurus A contributes a significant share to local gravity, but beyond that, dark matter dominates. The contribution from all satellites and from the intragroup medium remains smaller than the dark component across most of the volume. This partition is typical for groups in the nearby universe. It explains why the velocity field stays bound, and why the hot gas does not escape even when local heating episodes raise its temperature. A lesser-known detail is the way the halo's concentration encodes assembly history. Systems that have grown smoothly tend to have higher central concentrations at fixed mass than systems recently stirred by equal partners. The outer appearance of Centaurus A's halo with a calm velocity envelope and a continuous decline of intragroup brightness points to growth by repeated small additions and by slow inflow along the web, rather than by a recent group-scale merger. The sign is statistical rather than absolute. It complements the larger picture of an elongated but ordered group. On these scales, weak gravitational lensing is faint because the system is nearby, yet even subtle. Shears in background galaxies can be stacked to give a projected mass map. Where such maps are available, they place the mass peak close to the light peak of Centaurus A, and show contours that round off with radius. This independent view supports the field traced by motions and by hot gas. The three methods together, motions, pressure and lensing, tie the mass model to observables with few shared assumptions. The satellites sample the well at many radii. Some follow nearly radial paths, plunging inward and then slowing near apocenter. Others travel on more circular tracks that average the field over azimuth. Their orbits tilt at many angles relative to the projected plane of the sky. Over time, weak dynamical friction slowly drains energy from the most massive satellites, drawing them inward. Dwarfs feel little friction and can keep long-lived orbits. The census of satellites thus contains both long-term residents and recent arrivals, all moving under the same potential. The outer halo also gathers and holds diffuse starlight. Tidal stripping during past encounters releases stars into the group field, where they form a very faint envelope around the brightest galaxy. This intragroup light carries the kinematics of the halo rather than of the inner galaxy alone. Its slow fall with radius supports the conclusion that the mass profile stays extended and smooth. Photometry at low surface brightness levels detects this envelope and shows that it connects to the stellar halo of Centaurus A without a sharp break again, speaking to a shared gravitational structure. Temperature and entropy in the hot gas carry thermodynamic meaning at this radius. Entropy rises outward, a signature of early shock heating and gentle compression in the group potential.
The universe does not
Pressure
hurry.
declines with radius according to the
Even-
weight of overlying gas. These gradients limit convection and keep the medium layered. They also set a background for any disturbances launched by central activity. Weak waves can travel through this stratified atmosphere and dissipate slowly spreading energy without large mixing. From the vantage of group scale, the note is simple. The medium is held in a stable configuration by the halo and changes slowly. Uncertainties remain in detail. The exact axis ratios of the halo are not directly observed in 3 dimensions. Converting a projected shape into a full geometry leaves ranges that models must cover.
In plasma.
The fraction
How
of
X-ray
non-thermal
brightness
support in the
records
gas
the cluster's
varies with
subtle
radius
acts of
and
heating
introduces
and motion.
small shifts in mass derived from hydrostatic balance. The number of very faint satellites on the edge of detectability affects kinematic fits at large radii. Even with these caveats, the combined evidence returns a coherent picture. A dominant dark matter halo anchors the group. Hot gas sits in balance within it. Satellites orbit in the same field, and diffuse starlight follows the same decline. The halo also defines the scales on which later smaller processes unfold.
Earth
Orbital
breathes
periods
in
for satellites are set
strata
by the
decay.
depth of the
Weather
potential
becomes
and by
climate.
distance from the centre,
Climate becomes
running from
stone.
hundreds of millions to a few billions of
The
years.
Milky Way bends
Sound crossing
gently at
times in
its
the hot
rim.
medium span similar ranges across group radii. These slow clocks frame any disturbances that arise closer in. They also determine how quickly the outer gas can respond to
Endurance
changes near the
in
centre.
this galaxy
The response is
means
measured in
learning how to
tens to
fade
hundreds of millions of
without
years, not in
vanishing.
days or years, and it remains modest because the background gradients are shallow. The view remains strictly at group and halo scale. It does not enter the bright body of the galaxy or any inner structure. It rests on the deep extended mass that holds the Centaurus A group together, on the hot medium that fills the volume on the satellites that trace orbits through the same field, and on the faint starlight that spreads under the same pool. The shape is smooth, slightly elongated and stable over long times. The profiles of pressure and entropy are ordered. The motions of galaxies match the depth
The
implied by
mysterious
gas and
hollows
light.
in the cluster's X-ray
The outer setting is now fixed as a bound, extended halo, with a calm, thin atmosphere and a population of satellites moving within one well. This frame sets the conditions that all inner regions must respect and supplies the timescales against which any inner change proceeds. Far from the bright body of the galaxy, 2 wide regions spread into the group medium like low diffuse hills of radiolight. These are the giant lobes of Centaurus A. Each lobe is filled with relativistic plasma, a mix of fast electrons and magnetic fields that together produce synchrotron radiation. The emission is not visible to the eye. It appears in radio maps as broad, soft structures that reach hundreds of thousands of light years from the galaxy's centre. Their edges are not sharp walls. They fade slowly into the thin gas that fills the space between group members. The shapes are uneven and slightly asymmetric,
Heat
with
that
gentle
refuses
bends
to
that follow the
cool.
larger scale
Why the
geometry of the
cluster's gas
surrounding
remains
halo.
hot, even
The
as it
lobes
radiates
mark
its
where
energy
energy has
into
been
space.
deposited over long intervals, and where it now expands, cools, and mixes with the group atmosphere. The radiation from the lobes carries a spectrum that falls more steeply at higher frequencies. This behaviour is a signature of synchrotron aging. Electrons lose energy as they spiral in magnetic fields and as they upscatter background photons to higher energies. With time, the highest energy electrons
Invisible
fade
architects.
first, and the
Dark
spectrum
matter
steepens.
sculpting the structure
By
of
comparing
Virgo,
brightness at several
unseen,
radio
but
frequencies,
everywhere.
maps can estimate the ages of different zones within a lobe. Regions with flatter spectra are younger in radiative terms. Regions with steeper spectra are older. In Centaurus A, these patterns indicate that the lobes have grown over tens of millions of years and that different
Somewhere near
patches
the
have been
rim,
energized
a
at
star's
slightly
orbit
different
tells a
times.
secret.
The
There is
magnetic
more
field
mass
in the
than meets
lobes
the
is
light.
weak compared with fields in dense galactic disks, but it is strong enough to shape the paths of charged particles and to set the synchrotron power for a given electron population.
Oceans
Polarization
are
of the
poor
radio
archivists.
light reveals that
They
the field is
recycle
ordered
even
over
their
large
own
areas.
shells.
Lines of
Where cold
polarization
gas
sweep
goes to
across the
vanish.
lobes in broad arcs, and Faraday rotation from the group medium in front changes their angle by small
Metallicity
amounts
peaks
that
toward
depend
the
on the
heart,
electron
a
density and
fingerprint
field along
of
the
all the
path.
stars that
Together,
live
these
and
measures show
died
that
here.
the lobes are magnetized volumes embedded in a still more diffuse hot gas, and that both field and plasma have reached a degree of large-scale order. The lobes do not sit motionless. They rise slowly through the group medium under buoyancy, the same way a light fluid moves upward in a heavier one. As they rise, they entrain a thin skin of the surrounding hot gas along their flanks. This lift leaves subtle changes in
cluster's
composition
hidden
in the group
heartbeat.
atmosphere,
Energy
visible as
cycles
gentle
through
ridges of
cavities and
higher
waves,
metal content
keeping
and as
the
small
inner gas
gradients in
alive.
pressure. The motion is subsonic
Light
or
from old
only
stars
weakly
takes a
supersonic in most
billion years
places,
to arrive,
so strong shocks are
still
rare in
looks
the outer
recent.
lobes. Where pressure differences do appear, they are spread across broad
slow
regions
collision
rather than focused into narrow
never
fronts.
ends.
The work done by the lobes on the ambient gas is
They
measured
call
by the
it
volumes
one
they displace
galaxy,
and the pressure that confines
but
them.
its light carries
Even
the
this slow
stories
work
of
reshapes
hundreds.
the medium over long times, carving cavities that later relax and mix
Gravity's
back into
gentle
the
net.
background. The outer edges of the lobes meet environments that vary with angle. Along the main elongation of the group, the external pressure gradient is different from the gradient across the minor axis. As a result, one lobe can expand more easily than the other, or one side of a lobe can broaden into a wing, while the opposite side remains narrower. The net effect is a set of outlines that echo the
quiet
large-scale
power
anisotropy of
of
the halo
radios.
and the direction of supply along the web. The outermost radio contours of Centaurus A show such gentle asymmetries consistent with the group's elongated mass distribution. Within the lobes, faint filaments appear in high-quality radio maps. These are narrow, brighter strands of synchrotron emission that thread the broader glow. The strands may trace places where the magnetic
universe
field
does
is
not
locally
hurry.
stronger, or where mild
Even-
compression has enhanced the electron density. They are not rigid wires. They curve and branch, and their contrast varies
The
with
black hole's
frequency.
gravity
The
writes
presence
in
of these
invisible
filaments
ink,
indicates that
and
the
the
lobes
stars
carry internal
obey the
structure,
sentences.
even where their average pressure remains close to that of the outside medium. These modest contrasts can help keep the field organized, and can lengthen the time over which the lobes remain bright at a given frequency. The plasma also interacts with the sea of background photons that fills space. Electrons in the lobes scatter these photons to higher energies. The most abundant background is the cosmic microwave
History
background,
written in
a
plasma.
field of low energy
How
light
X-ray
left from
brightness
early
records
times.
the cluster's
When
subtle acts
fast
of
electrons
heating
collide with this
and
field,
motion.
they produce higher energy photons. This process complements synchrotron emission and removes energy from the same electrons. Where the magnetic field is weaker, inverse Compton losses on the microwave background become more important, and the synchrotron spectrum steepens more quickly. By comparing radio brightness with high-energy light from the same regions, maps can estimate the balance between field strength and electron energy density. In Centaurus, a such comparison suggests that the lobes are close to a state
Earth
where particle and
breathes in
field
strata,
energies
Te.
are of the same order
Weather
over wide
becomes
areas,
climate.
a common outcome when
Climate
plasma has
becomes
expanded
stone.
and relaxed for long times in a gentle environment.
The Milky Way
The lobe
bends
sizes are large enough to
gently
cross
at its
regions of the
rim.
group where the density and
God,
temperature of the hot gas change slowly with radius. As the lobes move through this stratified atmosphere, they can excite long wavelength waves that travel outward
Endurance
and damp
in
over
this
many
galaxy
tens of thousands of
means
light
learning
years.
how to fade
These waves are weak
without
and leave only
vanishing.
slight ripples in pressure that are hard to detect directly in a group. Even without direct imaging, the physics predicts that some fraction of the energy stored in the lobes spreads in this way, broadening the region influenced by the radioplasma. Over times comparable to the buoyant rise time, the lobes relax and their boundaries blur, returning part of their volume to the hot medium. A lesser-known detail lies in the faint bridges that sometimes connect inner and outer
A
structures.
universe
In
measured
Centaurus,
in
the
soft
low-frequency
light.
maps reveal diffuse emissions that link the inner lobes to the outer pair,
cavities
indicating
in the
that the
glow.
volume has been replenished
The
more than
mysterious
once,
hollows
and that
in the
energy has
cluster's
reached the
X-ray
far zones along
brightness.
channels that reopen or brighten across cycles. The bridges are faint because aging electrons emit weakly at high frequencies, but at low frequencies their longer-lived populations show the paths by which plasma has moved. These connections support a slow, repeated growth of the giant lobes, rather than a single brief event. The border between lobe and ambient medium is a contact surface that can be smoothed by magnetic draping. As the lobe moves field lines in the group, gas can wrap around its outer face, strengthening the field parallel to the boundary and stabilizing it against mixing. This draping reduces the growth of small instabilities that would otherwise fold the edge and exchange mass rapidly. Observations of polarized radio light across the edges of the lobes in Centaurus A are consistent with such stabilization, with higher degrees of order near the rims than in the interiors.
Why the cluster's
The result
gas
is a boundary that
remains
stays
hot, even as it
coherent over large
radiates its
angles,
energy into
while
space.
still allowing slow leakage and diffusion over very long times. The energy content of the lobes is large on group scales. It is counted by multiplying the pressure that confines them by their volumes, and by adding a modest factor for the work done as they rise and expand. The sum compares well to the energy needed to alter the thermal state of a significant fraction of the nearby group medium. Even when
Invisible
averaged
architects,
across long
dark
times,
matter
the power
sculpting the
implied by
structure
these
of
totals
Virgo,
is sufficient to
unseen,
explain the
but
persistence
everywhere.
of low entropy cores in similar systems, and the prevention of rapid cooling in their centres. Remaining at this outer radius, the point is only that the lobes hold enough energy to matter for their surroundings, and that this energy is packaged in wide light reservoirs that trade it with the
Somewhere near
environment
the
gently.
rim, a star's orbit tells a
Uncertainties in
secret.
the outer lobes
There is
reflect
more
limits of
mass than meets
projection
the
and
light.
sensitivity. Distances along the line of sight are not measured directly so true. Three-dimensional shapes carry a range. The exact mix of particle species in the plasma is not
Oceans
fully
of poor
known.
archivists.
Electrons are
They
traced by
recycle
synchrotron
even their own
radiation,
shelves.
while heavier
Where
particles make
cold
less
gas
direct
goes to
signals.
vanish.
Even with these cautions, the broad properties remain secure. The lobes are large magnetized buoyant and
Metallicity
aging.
peaks toward the
Their
heart,
spectra
a
steepen with
fingerprint
distance
of
from
all
younger
the
zones.
stars that live
Their
and
polarization
die
marks
here.
ordered fields, and their presence reshapes the group medium on long timescales. The scene at this step ends with the outer structures in view. Two broad radio-bright volumes fill a significant fraction of the group's inner space. They expand slowly into a stratified atmosphere. They carry ordered magnetic fields and long-lived electrons. Their edges are smooth with slight
cluster's
asymmetries
hidden
that match the outer halo.
Energy
Their
cycles
internal
through cavities
filaments
and
add
waves,
texture without sharp
keeping the inner
contrast.
gas alive.
They store and disperse energy over
Light from
millions of
old
years.
stars takes
Far
a
from the
billion
luminous
years
dust
to
layer
arrive,
and bright inner
but
body,
still looks
these lobes
recent.
give the first clear sign that Centaurus A affects its surroundings
slow
across very
collision
large distances,
that never
not with
ends.
sudden shocks, but with wide, persistent pressure and light.
They call it
The
one
region remains
galaxy.
quiet to the eye and
But its
active to
light
instruments
carries
that
the
read radio
stories of
waves and
hundreds.
gentle changes in the background of space. Around the radio lobes
Gravity's
and extending
gentle
through the
net.
space between group members, a thin atmosphere of hot gas fills the volume. This intragroup medium is made of electrons and ions moving fast enough that atoms do not remain bound. Its temperature reaches many millions of degrees Celsius. At such heat, the gas emits X-rays with a smooth glow, produced when electrons are deflected by ions, and it also
quiet
shows
power
faint lines
of
from heavy
radio.
elements, mixed into the gas by earlier generations of stars. The brightness is low because the gas is thin, yet it is measurable over wide areas. Where brightness rises, density is higher. Where the spectrum hardens, temperature increases. Combined maps of brightness and temperature become maps of pressure and entropy. Pressure measures how strongly the gas
The
pushes
universe
outward.
does not hurry.
Entropy, defined here as
Even-
heat content per particle, adjusted for density, rises with radius in a stable atmosphere that resists overturning. These maps reveal
The
a
black
medium
hole's
that is
gravity
layered and nearly
writes in
imbalanced with the
invisible
group's
ink,
gravitational
and the
field.
stars obey
Features
the
appear on top of the
sentences.
smooth gradient. Broad arcs trace places where pressure changes slightly more quickly than in the surroundings. Edges align with sections of the radio lobes and curve around them. In some zones, temperature rises just inside an edge, while density falls the pattern, but marks a weak shock travelling outward through the hot gas. In others, Temperature drops while density rises at nearly constant pressure, the signature of a contact boundary where cooler gas slides past hotter gas without strong mixing. The first type adds heat, the second repositions it. Both are present in groups where central activity has launched waves and where minor motions have stirred the core. The hot gas around Centaurus A carries both types in modest form. The weak shocks are gentle. Their strength is read from the jump in temperature and density across a thin layer. Ratios only slightly above unity indicate speeds near the local sound speed. At group temperatures, the sound speed is a few hundred kilometers per second. A shock at that speed carries energy outward, but does not tear the atmosphere. It leaves behind a small increase in entropy and a ripple in surface brightness that fades with radius as the wave broadens and dissipates. Such waves can originate near the center during episodes that inflate inner lobes and then travel through the hot gas over many tens of thousands of light years. By the time they reach the outer regions, they appear as barely visible crests that add a little heat across wide angles. The contact edges are longer lived. They outline regions where gas with slightly different histories meets. Cooler, denser parcels sometimes nudge from the center, by slow motions slide along paths set by the gravitational potential. Magnetic fields drape around their leading faces and suppress mixing across the boundary, keeping the edge sharp to X-ray instruments. At the same time, heat flows along field lines more easily than across them, so temperature differences can persist where geometry limits cross-field conduction. The result is a layered pattern of arcs and lanes that remain in place for long periods, compared with the time it takes sound to cross the region.
X-ray brightness.
Pressure maps highlight these structures by showing small deviations from sphericity. The pressure field mostly declines with radius as expected in a hydrostatic atmosphere. Where a weak shock has passed, pressure rises slightly along a thin shell. Where a cavity from an inner lobe has pushed outward in earlier cycles, pressure contours bend around the displaced volume. These bends are modest in a group, yet they can be traced when exposures are long and background is low. They show that mechanical work has been done on the gas, and that the energy has been distributed over large areas by waves rather than by a single strong front. Temperature gradients add another dimension. In directions where radiolobes expand more freely, the surrounding gas often shows slightly higher temperature and lower density than in the perpendicular directions, reflecting local compression and slower refilling by ambient material. Where motion of satellites has stirred the atmosphere, patches of cooler gas mark the wakes of those passages.
Even as it radiates
Each effect
its
is
energy
small,
into space.
yet together they give the hot medium a textured look, superposed on a smooth decline. Entropy profiles at group radii remain monotonic and rising, which indicates that the atmosphere as a whole stays stable against wide convection, even while small features move within it. The metal content of the gas is not uniform. Elements such as iron, silicon and sulfur appear in faint X-ray lines and allow abundance to be measured. Values are higher near the center and decline outward with slight ridges along paths where lifted gas has reached larger radii. These ridges align with parts of the radio structure, and with weak pressure features pointing to a link between mechanical uplift and chemical distribution. The amounts involved are small compared with the total mass, but large enough to matter for cooling, because line emission from heavy elements makes radiation more efficient at group temperatures. In places where abundance is higher, cooling times shorten slightly, all else equal, and the balance between heating and cooling depends more on the timely arrival of waves. A lesser-known detail appears in the way the outer lobes modify the group medium, even where shocks are absent. As lobes rise, they displace gas and create broad, low-contrast cavities. The surrounding atmosphere responds by gentle inflow from the sides, and by the formation of faint circulation cells that return gas behind the rising volumes. Over many cycles, this slow stirring spreads heavy elements and softens small gradients without fully mixing the atmosphere. The effect is easiest to detect as a mild smoothing of abundance profiles and a subtle flattening of pressure ridges at radii, where older lobes have already risen and mixed. The intragroup medium also leaves a weak mark on the background radiation that fills space. Hot electrons scatter a tiny fraction of low energy, background photons to slightly
Light
higher
from
energy,
old stars
changing
takes
the
a
brightness
billion
by a
years to
small amount
arrive,
along the line of
but
sight.
still looks recent.
In a nearby group, this imprint is faint, yet it can be
A
stacked
slow
to give an
collision
integrated pressure measure
that never
complements
ends.
the X-ray view, which depends on density
They
squared
call it
rather
one
than on
galaxy,
pressure directly.
but its
Where
light
both signals are
carries the
available, the
stories
joint
of
map
hundreds.
strengthens constraints on pressure gradients and helps separate true
Gravity's
pressure edges from
gentlemen.
projection effects. Uncertainties remain where sensitivity and projection limit detail. The true three-dimensional shapes of edges and waves cannot be seen directly. A curved shell seen at an angle can appear as a sharper rim or as a broader rise depending on geometry. Separating a weak shock from a contact edge requires temperature on both sides, which needs deep data in low brightness regions. Allowing for these limits the presence of a stratified, nearly hydrostatic atmosphere with gentle pressure features and weak shocks stands on secure ground. The energy carried by the weak shocks is enough when integrated over large solid angles and long times to offset a significant fraction of the radiative losses in the inner group. The remainder is handled by
The
slower
universe
processes,
does not hurry.
viscous dissipation of small
Even-
motions, turbulent mixing seeded at cavity boundaries, and the redistribution of heat along field lines. None of these channels acts
The black
quickly.
hole's gravity
Together they keep
writes
the
in
atmosphere from
invisible
cooling in
ink,
bulk and
and
maintain the observed
stars
gradients.
obey the sentences.
The group environment also registers the passage of small satellites through ram pressure effects. Narrow soft tails sometimes trail gas-rich dwarfs, where the hot medium has removed outer layers. These tails fade into the background and do not dominate the pressure field, but they provide local tests of the ambient density and confirm the presence of a confining medium. Their alignment with orbital paths
The
adds
history
to the
written in
picture of a
plasma,
calm atmosphere
how
that still
X-ray
interacts
brightness
with moving
records the
galaxies.
cluster's subtle acts of
Remaining at
heating
this radius
and
and
motion.
not entering the inner galaxy, the view holds to the hot gas and its edges. The medium is thin and hot, its pressure declining outward and its entropy rising. Weak shocks mark past energetic episodes and carry heat gently across wide areas. Contact boundaries trace slow motions and maintain sharpness where fields limit mixing. Metallicity changes follow uplift and slow circulation. Pressure maps and temperature maps align to show a layered structure perturbed but not broken by activity. Waves travel
Earth
dissipate and are
breathes in
replaced by
strata,
later waves,
decay.
keeping the atmosphere close to
Weather
balance
becomes
with small
climate.
persistent work
Climate
rather than sudden
becomes
change.
stone.
The scene ends with this structure
The
in
Milky
place,
Way
a
bends
stratified
gently
X-ray
at its
bright
rim.
sea, held by the group halo shaped by weak shocks and smooth edges, and changing on timescales, long enough that its gradients remain readable, even as it records
in
the
this
passing of each
galaxy
ripple across the
means
field.
learning how
Beyond
to
the bright
fade
body of the galaxy, light
without
thins into a
vanishing.
wide halo that extends for many tens of thousands of light years. The glow is smooth at first glance, and then with deeper exposure shows gentle structure. Faint arcs and ripples curve around Centaurus A in broken rings. Narrow streams cross the halo at angles that do not match the main body. These features are tidal shells and debris from a past encounter that has redistributed stars into long paths under the
universe
common gravitational
measured
field.
in soft
Each shell
light.
is a place where many stars moving on similar elongated orbits slow near their
Cavities
shared
in the
turning
glow.
point and crowd
The
into a
mysterious
thin
hollows in the
surface.
cluster's X-ray
Because their
brightness.
speeds fall there, their surface density rises, and their light becomes just visible above the background. The shells are not solid walls, they're caustics in phase space mapped onto the sky. Their spacing reflects the time since the stars were first launched into these paths. The outermost arcs contain the stars that have completed fewer oscillations. Inner arcs hold stars that have made more passes through the centre. The pattern records a recent history in simple geometry on the sky. The stellar halo itself holds a mixed population. Old red stars dominate the light at large radius. In the deepest images, individual red giant branch stars can be resolved in the outermost parts, allowing counts that trace the halo profile directly. These counts show a steady decline in number with radius and small rises at the locations of shells and streams.
Heat that refuses to
The overall
cool.
gradient
Why the
confirms that the
cluster's
stellar
gas
body of
remains
Centaurus
hot,
A
even as it
extends
radiates its
far
energy
beyond
into
the dust
space.
lane and inner bulge, merging into a diffuse, nearly spherical envelope that sits in the same well as the dark matter halo and the intragroup gas. Globular clusters scatter across this halo. They are compact old stellar systems that orbit in the combined potential. Their colours divide into a more metal-poor family spread widely, and a more metal-rich family that concentrates toward the centre.
Invisible
The
architects.
ratio of these families
Dark
varies with
matter
radius,
sculpting the
in
structure
a way
of
consistent
Virgo,
with a galaxy
unseen,
assembled
but
both by
everywhere.
early in situ star formation and by later additions of smaller systems. Clusters aligned with streams often share kinematics, with the debris acting as bright tracers that confirm the path set by gravity. In Centaurus A, the cluster system is
Somewhere
rich and
near the rim,
extended,
a
giving many
star's orbit
handles
tells
on the
a
outer
secret.
mass distribution.
There is more mass
The
than meets
shells
the
and
light.
streams change the smoothness of the halo without breaking it. They add ripples to a profile that otherwise follows a slow, continuous fall. Their orientations are not random.
Oceans are
Many
poor
align
archivists.
roughly with the major axes
They
of the inner
recycle
body,
even their own
and with
shells.
planes expected from an
Where
accretion
cold
event
gas
that was
goes
not
to
face-on.
vanish.
Some arcs show slight misalignments from perfect ellipses, where the underlying
Metallicity
potential is
peaks
triaxial
toward the
rather
heart,
than spherical.
a fingerprint
These
of all the
departures help
stars
diagnose
that
the halo
lived
shape and the
died
orbit
here.
families available to incoming stars. The lightened shells is faint, which makes contamination by foreground stars and background galaxies a practical issue. Careful subtraction and colour selection separate these interlopers from the halo population. After this cleaning, the arcs remain, and can be followed for large angles before they fade into the background. The number of distinct shells visible at a given depth sets
The
a lower
cluster's
limit on how
hidden
many
heartbeat.
oscillations have occurred since
Energy
the encounter,
cycles through
and
cavities
thus
and
on the
waves,
time elapsed.
keeping the inner gas alive.
In Centaurus A, the count and
Light
spacing
from
point
old
to a
stars
relatively
takes a
recent
billion
merger on
years to
galactic
arrive,
timescales.
but still looks
Neutral
recent.
hydrogen observations complement the starlight.
A
At some
slow
radii,
collision
low surface brightness
that
gas
never
follows
ends.
curved paths that echo the stellar arcs, though the alignment
call
is
it
not
one
exact because
galaxy,
gas feels pressure
but its
and
light
dissipates
carries
energy
the
while
stories of
stars do
hundreds.
not. The presence of gas in the outer halo signals that the disrupted
Gravity's
companion
gentle
contained a
net.
significant interstellar medium, and that not all of it settled in the inner disk. Some clouds now ride on long orbits in the wide field, slowly changing phase under the heat of the group medium. The metallicity of halo stars carries additional information. Photometry of resolved red giants and spectroscopy of bright planetary nebulae indicate that the outer halo
quiet
includes
power
stars with a
of
spread of a heavy
radios.
element content. The mean metallicity is lower than in the inner body as expected if many of these stars originated in a less massive system. Gradients across shells can be subtle. Where present, they hint at a progenitor with internal metallicity structure whose stars were stripped in stages. The halo's chemistry thus supports a picture in which a gas-rich galaxy was
universe
accreted
does not
and then
hurry.
phase-wrapped into arcs,
Even-
while its gas was torqued, shocked, and partially retained nearer the centre. The kinematics of the halo are read from velocities of planetary
The
nebulae
black
and
hole's
globular
gravity
clusters.
writes in
Their line of
invisible
sight
ink,
speeds
and the
broaden with
stars
radius
obey the
in a way that
sentences.
reflects the depth of the potential and the mix of orbits. Along some streams, the dispersion narrows, showing that stars there share a more coherent motion. Crossing points where two debris paths overlap in projection show two populations with different velocities, confirming that the light belongs to different wraps of the same event rather than to a single thick structure. These measurements
The
fix the
history
mass
written
scale
in
at large
plasma,
radii and
how
confirm
X-ray brightness
that shells are
records the
dynamically
cluster's
cold
subtle
features
acts of heating
embedded in a
and
hotter
motion.
background of halo stars. The morphology of the inner body ties to the halo through the shells. The main galaxy shows a prominent dust lane and a warped disk at smaller radii. The outer arcs intersect the projected extensions of those structures at angles consistent with a companion that arrived on an orbit not aligned with the pre-existing symmetry. The broad alignment between some shells and the group's preferred axis echoes the tendency seen at larger scales for supply to arrive along filaments. Even so, the shell system is primarily a
Earth
tracer of the
breathes
most
in
recent
strata
significant
decay.
accretion event,
Weather
rather than
becomes
of ongoing
climate.
group infall.
Climate becomes
A lesser
stone.
known detail sits in the brightness profile
The
breaks
Milky
associated
Way
with shell
bends
systems.
gently at
Where
its
shells are
rim.
present, the radial profile of starlight can show a shallow bump or change in slope. In Centaurus, a careful fitting reveals such features at radii that match prominent arcs.
In this galaxy,
These deviations from a
means
single
learning
smooth
how to
law are
fade
small but
without
persistent,
vanishing.
and they record the mass deposited in discrete wraps. Over time, phase mixing spreads these features and softens the breaks, but at present they remain readable. The halo also hosts very low surface brightness plumes that do not close into shells. These are tidal tails from earlier passages of smaller satellites, or from later stripping of debris drawn out during the main encounter. Their paths are longer and more diffuse than shell arcs.
A universe.
They often point away
measured
from the galaxy
in
along
soft
directions where the
light.
potential slope changes more slowly. They add a second family of
Cavities in
structures
the
that,
globe.
while fainter, confirm an
mysterious
extended
hollows in the
history of
cluster's
minor
X-ray
interactions in
brightness.
addition to the dominant recent event. Uncertainties at this radius follow from projection and depth. Shells seen in 2 dimensions can overlap in ways that mimic continuity where none exists. Incompleteness affects star counts at the lowest surface brightness levels and near-bright foreground stars. Velocity samples are discrete and can leave gaps along a shell that hide small gradients. Allowing for these limits, the overall interpretation remains steady. A recent merger has placed stars on elongated orbits that crowd into shells. Streams and tails cross the halo. Globular clusters and planetary nebulae trace the same field, and the diffuse light declines with radius while carrying small ripples where debris gathers. The outer stellar halo is the first clearly visible record of the event that set much of the later inner structure.
Heat that
It is not yet
refuses
the
to
inner
cool.
disk or the dust
Why
layer.
the cluster's gas
It is the
remains
broad
hot,
ledger in which
even as it
phase-wrapped
radiates
stars,
its
like the
energy
simplest
into space.
account, a companion was added. Its stars now move in long shared paths, and those paths mark turning points as arcs across the sky. Remaining at this radius, the view holds on the halo, and its ripples extended light with shells that repeat at larger to smaller radii streams, that cross clusters that ride the same orbits, and metallicity that drifts lower
Invisible
outward.
architects.
The halo keeps these
Dark
features for
matter
spans
sculpting
long
the
compared
structure
with the
of
time
Virgo,
between inner episodes,
unseen
so
but
that even
everywhere.
as the centre changes more quickly, the outer record remains visible and sets context for the next inward step. Gas that is cool enough to keep its electrons bound gathers around Centaurus A in wide, faint structures that radio maps trace with precision. This neutral hydrogen reveals itself
Somewhere
through a
near the
line
rim,
at a wavelength
star's
of about
orbit tells a
21
secret.
centimeters,
There is more
produced when the
mass than
spin of
meets
the
the light.
electron in a hydrogen atom flips relative to the proton. Instruments that measure this light map where the gas lies, and from small shifts in wavelength how it moves along the line of sight.
Oceans are poor
The result is a
archivists.
picture of envelopes
They
and
recycle
rings that
even their
extend
own
far beyond the
shells.
bright, dusty
Where
body of the
cold
galaxy.
gas goes to
The
vanish.
distribution is not a thin, calm disk. It is warped, broken in places, and laced with clouds that sit
Metallicity
above and below
peaks
the main
toward the
plane.
heart, a
The largest
fingerprint
feature
of
is a
all the
broad ring that
stars
wraps around the
lived
galaxy
and
at many
died here.
tens of thousands of light years from the centre. Its shape on the sky is an elongated oval whose tilt changes with radius. This change in tilt is the warp. It means that the gas orbits do not all lie in one plane, but rather in planes that slowly twist as distance increases. The warp aligns only partly with the stellar body. In some sectors, the ring crosses behind or in front of the main
The
light.
cluster's hidden
In others,
heartbeat.
it bends away.
Energy cycles
The
through
pattern
cavities
speaks
and
to a
waves,
system that is still
keeping the
settling
inner
from the
gas
past
alive.
encounter and has not yet reached a single
Light from
steady
old
geometry.
stars takes a billion years
Kinematics
to
complete
arrive,
the picture.
but still
By
looks
measuring
recent.
the wavelength of the 21 centimeter line across the ring, a velocity
slow
field is built.
collision
In a simple
that
flat
never
disk,
ends.
contours of equal speed would trace smooth mirror
They
symmetric
call it
curves,
one
and the
galaxy,
change in speed with
but
radius
its
would
light
follow a
carries
single
the
rotation
stories of
curve.
hundreds.
Around Centaurus A, the contours twist.
Gravity's gentle
Speeds
net.
vary with position in ways that require the tilt of the orbits to change with radius and with angle. This warped rotating ring precesses slowly in the gravitational field of the galaxy and the surrounding halo. The precession is the gentle turn of the orbital planes over time, a response to the fact that the potential is not perfectly spherical. Where the ring crosses
quiet
itself in
power
projection,
of radios.
position velocity diagrams show two families of speeds along the same line of sight. The two families belong to gas at different radii, whose tilted planes happen to lie along the same view. Such diagrams also show small departures from pure rotation, mild streaming along the ring at the places where its shape bends most strongly, and faint drifts toward the centre along short bridges that connect clumps. These non-circular motions are modest, but real. They mark gas that is responding to the combined pull of the inner galaxy, the outer halo, and the leftover torques from the merger that made the dust lane and shells. Clouds outside the main ring add to the field. Some lie above the plane by many thousands of light years and move on paths that intersect the ring only in projection. Others trail away along the direction of known streams of stars and likely share the same origin in strip material. Their velocities are close to the rotation of the ring where they pass nearby, and differ by small offsets where they are more detached. The combined effect is a thick flared distribution, in which the surface density of gas declines smoothly with radius, but the vertical spread grows in the outskirts. In places where the ring bends, most holes and low-density gaps appear. These are not empty cavities in the strict sense, but areas where the gas column is lower than in the surrounding arcs. The pattern suggests that differential precession stretches some sectors and compresses others, leaving alternating zones of higher and lower column along the same average radius. Where compression is mild, nothing more happens at this step. The gas simply thickens along the arc and shows stronger 21 centimeter emission. Where stretches are mild, the signal softens. The overall ring remains intact and the gaps do not break it. The radial extent of neutral hydrogen is greater than the bright optical body. In deep radio maps, emission continues into regions where starlight is only a faint halo, and where shells and streams are the dominant optical structures. Along some shells, faint neutral clouds follow the same curves with small offsets, as if the gas component of the accreted galaxy took a similar but not identical set of paths. Because gas can lose energy through shocks and radiation, while stars cannot its orbits damp more quickly. This explains why neutral hydrogen gathers into a ring, while many of the stars still trace sharper shells. A lesser known detail appears in the shallow gradient of velocity dispersion across the ring. The line profiles of the 21 centimeter emission are not infinitely narrow. Their widths carry contributions from thermal motions and from turbulence. In Centaurus A, the widths broaden slightly where the warp bends most strongly and where the ring crosses the bright body. The broadening indicates extra stirring in those zones, likely from weak shocks, where gas streams meet, and from shearing as adjacent tilted planes slide past one another. Even so, the dispersion remains low compared with the rotation speed, which means the ring stays supported mainly by ordered motion and not by random agitation. The warp has a regular form when expressed as a set of tilted rings. Each ring can be described by its radius tilt angle and line of nodes, the line where the ring's plane crosses the reference plane. Moving outward, the tilt and the line of nodes change smoothly. This regularity lets models reconstruct the three-dimensional geometry and the distribution of mass that shapes it. Fits that match both the brightness and the velocity field require a potential that is not spherical, and a gas distribution that extends farther on one side than the other.
Refuses to cool.
The asymmetry aligns
Why the
with the
cluster's
direction
gas
of the larger scale
hot,
group
even
elongation,
as it radiates its energy
and with the outer
into
radio
space.
structures tying the neutral hydrogen into the same broad frame. Neutral hydrogen also fills short bridges that appear to link the main ring to smaller clouds and faint companions. These bridges are thin and low in surface brightness. Their velocities lie between those of the ring and those of the attached clumps consistent with tidal connection. Some bridges are likely remnant tails from the merger that produced the dust lane.
Architects.
Others may come from
Dark
later
matter
minor
sculpting the
accretions.
structure of
Their
Virgo.
presence shows that gas
Unseen,
continues to move
but
along
everywhere.
gentle paths toward the main body, even after the principal event. The total mass in neutral hydrogen is small compared with the stellar mass, yet large enough to matter dynamically in the outer ring where stars are sparse. Its self-gravity contributes to keeping the ring coherent, while the dark matter
Somewhere near
halo
the rim,
sets the
a
deeper
star's
background
orbit
pull.
tells a secret.
The ring's gradual
There is
precession
more
and
mass
slow
than meets the
damping
light.
indicate that it has lived through many orbital periods, but not yet through enough to erase the warp. Timescales inferred from the tilt pattern and speeds place the settling in the range of
Oceans
hundreds
are
of
poor
millions of
archivists.
years, which is
They
consistent
recycle
with the
even their
recent
own
appearance of
shells.
outer shells.
Where cold gas goes to
Uncertainties
vanish.
at this radius come from projection and sensitivity. Gas on the far side of the galaxy
Metallicity
can be
peaks
absorbed by
toward the
dust lanes
heart,
in front at
a
some
fingerprint
wavelengths,
of all the
and can be
stars
confused
that
with
lived
emission from
and
closer
died
radii
here.
if the tilt brings their lines of sight together. Low surface brightness clouds can fall below detection thresholds, leaving gaps in maps that look like holes when they're simply limits. Even with these cautions, the presence of a wide-warped ring and of extended envelopes is secure, and the sense of their rotation and precession is clear. Magnetic fields thread the neutral gas as well, though their measurement is indirect here.
The cluster's hidden
Polarization in background
Energy
sources seen through
cycles
the
through
ring
cavities and
rotates by
waves,
small
keeping
amounts
the
that
inner
depend on
gas alive.
electron content and field along
Light
the
from
path a
old
quantity
stars
that is
takes
small
a
in
billion
neutral
years
regions.
to arrive,
Where the
but
ring
still
overlaps
looks
with
recent.
warm ionized layers, the rotation strengthens slightly,
slow
suggesting
collision,
that fields align
that
with the
never
larger warp
ends.
structure over broad angles. The field's not strong enough to
They call
dominate
it
the
one
dynamics,
galaxy,
but they can help guide how
but its
small
light
clouds
carries
slide along the warp
stories of
and how
hundreds.
thin sheets resist shear. The environment around the ring
Gravity's
is the hot
gentle net.
intra-group medium already described farther out. Pressure from that medium is low compared with the inner body, yet it is not zero. It confines the outermost neutral clouds and may aid in keeping the flared envelope from evaporating quickly. Evaporation at the boundaries still occurs where clouds are small and where conduction is efficient. This creates a mixture of phases around the ring,
The quiet
neutral
power
cores with warmer
of
skins that
radios.
radiate weak optical lines and absorb background starlight in narrow bands. Remaining strictly at this radius, the view stays with distribution and motion. A broad neutral ring wraps the galaxy tilted and twisted with radius. Velocities trace ordered rotation modulated by warp and by small streams. Clouds sit above and below the main plane.
universe does
Thin
not
bridges
hurry.
link clumps and ring.
Even
Gaps mark zones stretched by precession rather than empty cavities. The ring's geometry encodes a recent disturbed history and a
black
present
hole's
state that is
gravity
still settling
writes
under the
in
pull of the
invisible
halo
ink,
and the inner
and
galaxy.
the stars
The scene
obey the
ends here with the
sentences.
neutral hydrogen acting as a wide ledger of motion and shape written in cool gas that keeps the memory of an encounter while it turns in long, slow paths around the centre. Across the bright body of Centaurus A, a broad dark band divides the starlight into two unequal wings. This is the dust lane, a thick warped disk of gas and dust that crosses the galaxy on a steep angle to the outer
History
halo
written in
and to the
plasma.
group's preferred
How
axis.
X-ray brightness
In optical
records the
images, it
cluster's
appears as an
subtle
irregular
acts of
belt
heating
with ragged
and
edges,
motion.
knots, and faint scallops, where uneven columns of dust absorb background light. The belt is not a uniform sheet. It is a layered structure whose midplane is dense and whose surface is flared and clumpy. Radiative transfer through this structure, light passing through and scattering from grains, produces a complex pattern of extinction that changes with position and with viewing angle. Where the column is highest, the background is almost erased. Where the column thins, partial transparency
Earth
reveals
breathes in
stars
strata
beyond as a
decay.
faint reddened glow.
Weather becomes climate.
The dust lane's geometry
Climate
is read from the
becomes
combination of shape and colour. The near side is identified
Milky
by
Way
stronger
bends
extinction against the inner
gently
light,
at its
and by
rim.
sharper, more abrupt boundaries. The far side shows softer edges as scattered light fills in behind thinner filaments. The belt is also warped. Its line of nodes
Endurance
twists with
in
radius,
this galaxy
and its tilt
means
changes
learning
from the
how
inner
to
to the outer
fade
parts.
without
This
vanishing.
warp echoes the pattern already traced in neutral hydrogen, but the dust lane sits closer to the centre and carries greater surface density. The misalignment with the stellar body speaks to a past encounter that brought gas and dust in on an inclined orbit. The grains that make the lane are small, solid particles composed mainly of carbon-rich and silicate materials with traces of ices in colder pockets. Their sizes span a range from tens of
universe
nanometers to
measured
fractions of a
in
micrometer.
soft
This
light.
mix sets how the lane dims and reddens. Starlight's shorter wavelengths are scattered
Cavities
and
in the
absorbed
glow.
more strongly than longer ones,
The
shifting the
mysterious
colour of the
hollows in the
background toward
cluster's
red,
X-ray
where light
brightness.
passes through. The ratio of total to selective extinction, a measure of grain size distribution, varies slightly across the belt, consistent with localized growth in dense regions, and with destruction in disturbed, irradiated edges. In the mid-infrared emission from warm dust, and from molecules known as polycyclic aromatic hydrocarbons, outlines the same lanes that appear dark at optical wavelengths. These bands brighten where small grains and molecules are heated by the ambient radiation field to temperatures of tens to hundreds of degrees Celsius. Their glow marks surfaces rather than depths. It highlights folds in the lane rims of filaments and the interfaces where the warped disk meets the older stellar bulge. The mid-infrared view confirms that the dust lane is thick with appreciable vertical extent above and below its mid-plane. Polarization of starlight passing through the belt adds another layer of information.
Why the cluster's gas
Aligned
remains
dust
hot,
grains
even as it
preferentially
radiates its
absorb and
energy into
scatter light
space.
along their long axes, imprinting a weak polarization on the transmitted light. The orientation of this polarization traces the magnetic field projected on the sky within the dusty disk. Across Centaurus, polarization vectors tend to follow the curvature of the lane, indicating fields aligned with the warped geometry. The degree of polarization rises where columns are moderate and drops where they are either too high, hiding background entirely, or too low, leaving little imprint. These measurements show that magnetic fields thread the dust lane coherently on kiloparsec scales and may help support its flared surfaces against shear. Kinematics of the dust are not measured directly, but gas associated with the lane provides the velocity field. Ionized gas seen in optical lines sits in thin skins at the surfaces, where starlight and shocks have warmed and ionized outer layers. Its velocities reveal rotation in the warped plane, and small departures from circular motion near bends and folds. Molecular gas
Oceans
traced by
of
carbon
poor
monoxide fills the
They
interior with
recycle
higher
even their own
density
shelves.
and moves on the same
Where
general
cold gas
orbits with
goes
larger
to
dispersions. Together, these phases show that the lane is a rotating tilted disk, with additional structure
Metallicity
built by
peaks
differential
toward the
precession,
heart,
and
a
by lingering
fingerprint of
torques
all
from the
the
merger that
stars
placed
that
it.
lived and died
At the inner
here.
edge, the lane's dust rises steeply above the central light and obscures much of the inner body. Radiative transfer models that combine absorption and scattering reproduce the asymmetric brightness on either side of the lane and fix the three-dimensional tilt within ranges. In these models, the near side crosses in front of the central bulge and hides the nucleus at optical wavelengths, while the far side lies behind and
cluster's
dims
hidden
only the
heartbeat.
outer light.
Energy
The same
cycles
models
through
show that a
cavities
small
and
change in
waves,
tilt with
keeping
radius
the inner
can
gas
account for the
alive.
curling silhouette of the belt's edges,
Light
and for
from
the way
old
narrow
stars
filaments
takes
appear
a
to wind
billion
across the
years
face
to
of the
arrive,
galaxy.
but still looks
Superimposed on this broad geometry are fine structures,
A
lanes
slow
only a few
collision
hundred light years wide,
that never
knots where
ends.
several filaments meet, and small holes where
They call it
foreground dust
one
is thin enough
galaxy,
that background stars
but its
shine
light
through with less
carries the
reddening.
stories of
These
hundreds.
features are not static. Subtle offsets between the
Gravity's
positions of
gentle
knots at
net.
different wavelengths indicate motion at modest speeds within the warped disk. The timescales are long compared with human observation, yet over millions of years these motions smooth some features and sharpen others, as shear stretches, clouds into longer threads, and as compression along bends thickens them. The dust lane intersects the outer shell system in projection. In places, a
quiet
shell
power
passes behind the lane's dark
radios.
band and disappears only to reappear beyond the nearest dusty edge as a faint arc. This crossing confirms that the lane sits inside the broad stellar halo. It also shows that the dust and gas plane is tilted enough that some shells intersect its volume, where stars pass behind a thicker column and their light dims. The relative depths inferred from
The
such
universe
crossings
does not
help
hurry.
place the lane in three dimensions without assuming a specific orientation beyond the measured warp. The lane's effect on observed colours is strong and requires careful
black hole's
correction before
gravity
properties of the inner
writes
stellar
in invisible
populations can be
ink,
derived.
and the stars
Maps of
obey
reddening
the
built from
sentences.
multiband images serve as masks that restore approximate intrinsic light levels when applied to the absorbed regions. Residuals after this correction reveal light from the underlying bulge and show that the dust lane covers a significant fraction of the central galaxy, yet does not fully hide its structure. Even with these corrections, the inner few thousand light years remain complex, because patchy extinction varies on small scales that cannot be fully resolved across the entire area. The composition of the dust varies with position. Ratios of mid-infrared features indicate changes in the abundance of small molecules relative to larger grains with smaller particles, more abundant in irradiated surfaces and larger grains dominating in shielded interiors. Far-infrared colours which trace cooler dust peak where columns and shielding are highest. In combination, these diagnostics show a stratified lane whose outer skins are warmer and more chemically processed, and whose mid-plane is cooler and more molecular. The total dust mass in the lane is large for a nearby galaxy, consistent with an origin in a gas-rich system that was captured and spread into a disk. Its spatial distribution remains clumpy, suggesting that the process of settling toward a thinner, more regular plane is ongoing. A lesser-known detail lies in the faint scattering halos around bright inner stars seen near the edges of the lane.
In this galaxy,
these halos are small increases in blue light caused by starlight scattering off dust at shallow angles into the line of sight. Their presence indicates that even where absorption is strong, some light escapes along longer paths and returns at lower surface brightness to fill in the darkest regions. This scattered component must be included when modelling the true column of dust and the radiation field inside the lane. Uncertainties at this radius follow familiar lines. Three-dimensional shapes inferred from two-dimensional projections carry ranges. The relative contributions of absorption and scattering change with grain properties that vary across the lane. Foreground stars and background galaxies add small contaminants that require masking. Despite these limits, the main description remains stable. A thick, warped disk of dust and gas crosses the galaxy, aligned with neutral hydrogen, at larger radii, but denser and more clumpy. It reddens and dims the inner light according to position. It shows polarization aligned with its curves, and it rotates in a tilted plane with small departures, where bends and folds concentrate material. Remaining strictly within this region, the view ends on the lane itself, a dark band that is not a single stripe but a layered volume of grains and gas, set at an angle to the old stellar body holding a memory of its arrival in its warp, and shaping what can be seen of the centre by the way it handles light. Inside the thick dust lane, gas and dust organise into a ring where conditions favour the birth of young stars. The ring spans a few thousand light years and lies within the warped disk that crosses the main stellar body. It is not a perfect circle. It is elongated by projection and by the tilt of its plane, and its thickness varies where the warp bends. Along this structure, gas compresses in arcs and knots, where surface density is higher and shear is modest. Cold clouds become gravitationally bound and begin to form clusters. The ring is identified in several ways. In the ultraviolet diffuse light outlines patches of recent star formation. In optical maps, hydrogen recombination lines mark ionized regions around hot, short-lived stars. In the mid-infrared, warm dust and simple molecules glow in bands that peak along the same lanes. In the far infrared, cooler dust rises in brightness where columns are largest. Together, these traces show a chain of sights that follow the geometry of the ring, rather than the older stellar isophobes of the bulge. The star-forming regions appear as clumps a few hundred light-years across, embedded in longer filaments. Their spacing is irregular, but shows a broad tendency for separation, comparable to the local thickness of the ring, a sign that gravitational fragmentation and shear act together. Kinematics within the ring are read from ionized and molecular gas. Rotation dominates. Velocities increase toward the inner edge, and decrease outward tracing arising and then easing curve appropriate for a system where the central mass grows towards small radii. Superposed on this ordered motion are small non-circular components streaming along the ring, where it bends most strongly, and short radial drifts where lanes intersect. Line widths are broader than would be expected for a perfectly cold medium.
The
extra width reflects turbulence, unresolved cloud-to-cloud motions and expansion of ionized gas around young stars. Even so, the
from
dispersion
old stars
remains a
takes
minority
1
share of
billion
the
years to
support against
arrive,
gravity.
but still
The ring
looks
is not
recent.
uniform in age. Color gradients and spectral indices
slow
change along
collision
its length.
that
Some
never
knots show
ends.
strong emission lines and blue continua that indicate
They
very
call
young
it
ages
one
of a few
galaxy.
million years.
But its
Others
light
show weaker
carries the
lines and
stories
slightly
of
redder
hundreds.
colors, consistent with tens of millions of years.
Gravity's
This spread
gentle
implies
net.
that star formation proceeds in episodes that drift with the gas, leaving behind young clusters that age as they orbit, while new knots appear downstream where compression is now strongest. The rate of star formation integrated over the ring is modest for a galaxy of this mass, on the order of a few solar masses each year. This rate is measured by combining ultraviolet, optical and infrared tracers to account for light absorbed by dust and re-emitted at longer wavelengths. The balance among bands varies from knot to knot, with the dustiest regions contributing more strongly in the infrared and the more transparent sectors brighter in the ultraviolet and optical. The efficiency with which gas becomes stars depends on environment. In segments where the warp brings lanes together and raises pressure, conversion proceeds
The
more quickly.
universe does not hurry.
In segments where shear is high, or where recent stirring has broadened the gas, the efficiency drops. On average, the ring converts only a small fraction of its molecular mass
The
into
black
stars
hole's
per
gravity
local dynamical
writes in
time,
invisible
leaving a
ink,
reservoir that
and the
persists over
stars
many
obey
orbits.
The sentences.
The coldest phase of the ring is traced by carbon monoxide and by rarer isotopologues that sample higher densities. Maps show clumps and short filaments that fill the interior of the dust lane. Their surface densities peak where the ring intersects the central minor axis and along sections where the warp is steepest. Temperatures in these clouds remain low, only tens of degrees above absolute zero,
The history
while their
written in
skins in
plasma,
contact with local
how
radiation
X-ray
fields
brightness
warm enough to
records the
emit in
cluster's
fine
subtle
structure
acts of
lines.
heating and motion.
The pressure from the surrounding stellar body and hot group medium confines the clouds and helps offset the disruptive effects of young stellar winds. Magnetic fields thread the ring. Polarized radio emission and the alignment of dust-induced optical polarization indicate fields that follow the warped geometry of the kiloparsec scales. These fields reduce mixing across layers and can raise the effective support against collapse in diffuse regions while guiding flows along the ring. Where fields are ordered and strong enough to matter, they can also collimate low-speed outflows from young
Weather
clusters,
becomes climate.
helping energy escape
Climate
without dispersing the
becomes
dense
stone.
cores that form the stars. Ionized gas
The
along the
Milky
ring
Way
shows
bends
moderate electron
gently
densities
at its rim,
and temperatures characteristic
not
of star-forming regions in metal-rich environments. Line ratios indicate high abundances of heavy elements consistent with gas that's been enriched by previous
in this
generations in the
galaxy
main
means
galaxy
learning how
and by
to
the
fade
accreted system that built the
without
dust lane.
vanishing.
These abundances increase cooling efficiency in warm gas and affect the balance among emission lines used to measure current rates. The stellar populations that the ring builds are compact and numerous. Star clusters populate its length-spanning masses from small open clusters to more massive systems that can survive for long times. Their spatial distribution follows the gas with concentrations near the inner edges of dense lanes and near
universe
points where filaments
measured
intersect.
In soft
Color
light.
magnitude diagrams of clusters show continuous formation over the past
Cavities
few
in the
tens
globe.
of millions of years,
The
with
mysterious
no
hollows in
single
the
brief
cluster's
burst
X-ray
dominating the
brightness.
sample. The ring's geometry affects what is seen at different wavelengths. On the near side, extinction is high and hides ionized regions that lie behind thicker dust. On the far side, the same regions are more visible, because the dust lane lies beneath them along the line of sight. Infrared maps partly erase this asymmetry by tracing dust emission, directly revealing a more complete chain of star-forming sites than optical maps alone. Radiative transfer models that combine absorption and scattering reproduce the observed differences between the two sides and help convert observed light into intrinsic rates. Compression in the ring has multiple causes. Self-gravity in the gas concentrates mass along arcs. Differential precession in the warped disk brings lanes together at some azimuths and separates them at others. Mild shocks arise where streaming meets bends and where clouds
Heat that
overtake one
refuses to
another along
cool.
converging paths.
Why the cluster's
Each
gas
process is
remains
weak on
hot,
its own,
even as it
but
radiates
together they
its
build the
energy into
conditions for
space.
bound cores. The result is a ring in which support from rotation and pressure holds most of the gas in place, while selected zones collapse into stars. A lesser-known detail lies in the presence of photodissociation regions that blanket the edges of molecular clumps. These layers sit between the ionized interiors of H2 regions and the cold cores. They emit in far infrared lines of carbon and oxygen, and in mid-infrared bands from small molecules. Their strength along the ring indicates that a significant fraction of the ultraviolet energy from young stars is absorbed locally and re-radiated, a fact that must be included when balancing the energy budget and when translating infrared brightness into star formation rates. The ring's interaction with the surrounding bulge is gentle.
A star's orbit
Stellar
tells a
gravity
secret.
shapes the background
There is more
potential
mass
and
than
sets
meets the
orbital
light.
speeds. Ram pressure from the hot group medium plays only a minor role at these radii compared with internal dynamics. The main exchanges are by radiation and by low-speed flows
Oceans
within the
are
warped
poor
plane.
archivists.
Over times
They
of
recycle
hundreds of
even their
millions of
own
years,
shells.
the ring slowly
Where cold
processes and
gas
drifts
goes
as
to
torques
vanish.
align it more closely with the preferred planes of the galaxy. During that time, it continues to build
Metallicity
stars at a
peaks
moderate
toward the
rate
heart,
and to
a
supply
fingerprint
clusters
of
that
all
will join
the
the broader
stars that
stellar body
lived and
as they
died here.
age and spread. Uncertainties at this radius come from geometry and dust. Extinction varies strongly on small scales, complicating corrections. Projection can blend distinct knots along the line of sight, making compact groups appear brighter and older regions fainter depending on superposition. Converting line and continuum light into star formation rates requires
cluster's
assumptions
hidden
about the
heartbeat.
distribution of stellar masses
Energy
at birth
cycles through
and about the
cavities
continuity
and waves,
of the recent
keeping
history.
the inner gas
These
alive.
assumptions are guided by nearby well-studied
Light
systems
from
but
old
retain
stars
ranges here.
takes a billion
Even
years
with
to
these
arrive,
limits, the picture is
but
stable.
still looks
The kiloparsec scale warped ring rotates within the dust lane.
recent.
It carries cold
collision
molecular gas in
that
clumps and
never
filaments.
ends.
It shows a chain of the young regions whose ages span
call it
several tens
one
of millions
galaxy,
of years, and
but
it
its
builds
light
stars at a
carries the
steady moderate
stories of
pace set by
hundreds.
gas supply pressure and shear. Remaining at this scale,
Gravity's
the view holds to
gentle
the
net.
ring and its work. Gas arrives along the warped disk and is gathered into denser lanes. Compression and modest shocks make bound cores. Young stars light their surroundings and warm dust that glows in bands along the same paths. Clusters populate the chain with ages that drift around the ring as gas moves. The ring keeps its shape while it turns
quiet
and
power
slowly processes,
radios.
and it continues to mark the inner galaxy with a clear belt of ongoing, orderly star formation, cut into the older light by the same dust that both hides and reveals it. Cold molecular gas collects inside the dust lane in a network of clumps, filaments, and short streams that follow the warped geometry and extend inward from the kiloparsec ring towards smaller
The
radii.
universe does not hurry.
This network is traced most clearly
Even-
by lines of carbon monoxide and by rare isotopologues that respond at higher density. Maps built from these lines show bright knots
The
a
black
few hundred
hole's
light years
gravity
across,
writes
embedded in
invisible
longer
ink,
structures that
and
curve with the lane.
stars obey
The emission is
sentences.
strongest where the ring bends and where lanes cross. Surface brightness declines toward the edges of the warped disk, but discrete clouds remain detectable far from the peak. Temperatures in the brightest clumps are low, only tens of degrees above absolute zero. Densities rise toward cloud centers where shielding by dust reduces dissociation of molecules and allows cooling to proceed. The result is a
history
layered
written in
medium cold
plasma,
cores
how
wrapped in
X-ray
warmer skins
brightness
and
records the
threaded by
cluster's subtle
weaker
acts
lines
of
from the
heat
surrounding
and
atomic
motion.
gas. Kinematics reveal ordered rotation modulated by drift and shear. Along the major axis of the warped disk, velocities increase toward the center and then change slope where gravity steepens. Superposed on this trend are small non-circular motions. Some filaments show inward streaming of several tens of kilometers per second, along paths that align with dust lanes seen in the near-infrared. Others show mild counterflows where shear bends a lane around a turn. Line widths exceed thermal values by wide
breathes in
margins,
strata
indicating
today.
turbulence and unresolved
Weather
motions among
becomes
many
climate.
subclumps.
Climate
Even
becomes
so,
stone.
dispersions remain a minority share of the overall support compared with rotation and cloud self-gravity.
At its rim.
The mass of the molecular reservoir is large for a nearby early type galaxy. Converting carbon monoxide brightness to mass requires a factor that depends on metallicity, excitation, and cloud structure. Measurements in Centaurus A indicate high abundances of heavy elements and gas that is neither extremely diffuse nor extremely compact on average. Using factors appropriate to these conditions returns a total cold mass sufficient to fuel the observed star formation for many tens of millions of years, and to supply inner regions if transport continues. The gas is not arranged as a thin, quiet disk. Filaments cross knots, merge, and lanes bifurcate. Intersections mark places where compression raises column density, and several of the youngest clusters lie next to those junctions.
Cavities in the
Between
glow.
intersections, filaments narrow and show weaker emission as shear stretches them. The overall pattern is consistent with differential precession in a tilted ring that continually brings some sectors together while pulling others apart. Magnetic fields follow the same curves. Polarized radio emission and the orientation of dust-induced optical polarization imply fields ordered along the warped plane over kiloparsec scales. Within clouds, field strengths are sufficient to contribute to support against gravity in diffuse layers, while leaving dense cores free to collapse. Alignment of fields with filaments guides heat flow along the long axis and reduces conduction across boundaries. This anisotropy helps cold cores survive in a galaxy that sits within a hot group medium. A lesser-known detail sits in the faint lines from molecules that trace transition layers, such as hydrogen cyanide and formal cation. These lines appear in compact peaks at a subset of carbon monoxide maxima. Their presence indicates pockets where density has crossed thresholds that mark imminent star formation, or strong external pressure. Their scarcity outside peaks shows that most of the network remains in a state supported by turbulence fields and external pressure without global collapse. The energy balance in the network is local. Ultraviolet radiation from nearby young stars heats outer skins which cool by emitting far infrared lines.
Invisible
Slow shocks
architects,
at a few tens of
dark
kilometers per
matter
second
sculpting
stir
the
gas at
structure of
filament
Virgo,
intersections
unseen,
and excite
but
molecular
everywhere.
hydrogen without destroying it. Cosmic rays and soft X-rays from the active nucleus contribute modest heating that falls with distance and with column. At the radii of the network, their effect is secondary to stellar and mechanical inputs. The combination maintains a wide range of
Somewhere near
temperatures
the
across
rim,
short
a star's
distances and
orbit
produces
tells a
the mixed
secret.
line ratios
There is
observed
more
along
mass than
individual
meets the
lanes.
light.
Transport toward the centre proceeds along narrow channels. Position velocity slices across the inner few thousand light years show streamers that deviate from circular rotation in the sense
Oceans are
expected for
poor
inward drift
archivists.
along the warped
They
plane.
recycle even
Their
their own
speeds are small
shells.
compared with orbital
Where
speeds,
cold
which implies
gas
long
goes to
delivery
vanish.
times and a steady rather than sudden supply. Occasional bends and breaks suggest that clouds share
Metallicity
angular
peaks
momentum by
toward the
soft
heart,
collisions,
a fingerprint
and
of
tides
all the
allowing a
stars
fraction of mass
lived
to move
and
inward,
died here.
while another fraction is deflected outward or remains in place. The inflow fraction varies with time as geometry changes the number and strength of intersections. The network interacts with the ambient stellar potential. Where the ring crosses minor axes of the bulge, compression increases, columns rise, and the carbon monoxide peaks. Where shear dominates, clumps elongate and line widths grow while surface
The
brightness
cluster's
falls.
hidden heartbeat.
Over many orbits,
Energy
torques from the
cycles through
triaxial
cavities
potential
and waves,
slowly change the
keeping the
orientation of
inner
orbits
gas
in the warped
alive.
plane, feeding the same cycle of convergence and
Milky Way
divergence
bends
that maintains the
gently
network
at
of
its
streams.
rim.
Neutral hydrogen envelopes overlap the outer molecular lanes. In those regions, carbon monoxide brightness drops while the 21 centimeter line remains detectable.
Endurance.
This
in
transition
this
marks where
galaxy
shielding
means
declines and
learning
where the
how
cold
to
phase
fade
becomes more mixed with
without
atomic gas.
vanishing.
The overlap also reveals sites where material from the outer ring can feed the molecular network by cooling along dust-rich paths into the warped disk. Dust-to-gas ratios are high compared with those in low metallicity dwarfs and support efficient molecule formation once column density rises above modest thresholds. The chemical state reflects enrichment by past generations in the main galaxy and by the captured system.
A universe
Uncertainties remain in the
measured
conversion from
in
line
soft
brightness to
light.
mass. The factor depends on clumpiness temperature and optical depth,
Cavities
all
in
of
the
which
glow.
vary across the network.
The mysterious hollows
Multi-line
in the
analyses
cluster's
mitigate
X-ray
these issues
brightness.
by fitting excitation models that include several transitions. Even so, mass estimates retain ranges at the tens of percent level. Kinematic decompositions also carry ambiguity where two filaments cross in projection. Careful use of channel maps and high spatial resolution reduces this blending, but in the densest regions some overlap persists. Within these limits, the picture is robust. A turbulent, magnetized, clumpy reservoir fills the inner warped disk. Filaments feed inward along preferred paths. Intersections compress gas and seed, both star formation and further drift. And dispersions remain moderate enough that most material stays bound to the lanes, rather than dispersing into the hot medium. The network's role in supply is cumulative. Over times of hundreds of millions of years, small inward drifts along many
Heat
paths
that
deliver enough
refuses
mass to
cool.
maintain the
Why the
circumnuclear
cluster's
structures
gas
described at
remains
smaller
hot,
scales.
even as it radiates its
At
energy
the same
into
time,
space.
star formation along the ring removes a share of the reservoir locally, and mixing at the surfaces returns a smaller share to warmer phases. The balance among these channels changes as the warped geometry evolves. Yet the total molecular mass and the pattern of filaments remain broadly similar over long intervals because inflow from the outer ring replenishes the network as it turns. Pressure from the surrounding environment confines the network and sets a floor-to-line widths. Even where turbulence decays, dispersions do not fall to the thermal scale, because external pressure and shear keep clouds broadened. This flaw helps explain why clumps persist without immediate collapse, and why star formation efficiency per orbit remains modest on average. Where pressure peaks locally as near inner bends or
Somewhere
cavity
near the
rims
rim,
from past
a
nuclear
star's
activity,
orbit tells a
the
secret.
network thickens
There
and
is more
brightens.
mass than meets the
These
light.
local responses show that mechanical events in the centre can influence the molecular lanes at kiloparsec scales without disrupting them. Remaining strictly within this region and not
Oceans
entering the
of
innermost
poor
jet or
archivists.
accretion flow,
They
the
recycle
view
even
ends
their
on
own
the cold
shelves.
network itself.
Where cold
Carbon
gas
monoxide,
goes to
bright
vanish.
clumps in a warped plane, filaments and short streams that carry small but persistent inward
Metallicity
drift,
peaks toward the
magnetic
heart,
fields
a
aligned with
fingerprint
lanes,
of all the stars
turbulence
that
that broadens
lived and
lines
died
yet
here.
leaves rotation dominant, and chemistry that records high metallicity and layered shielding. The molecular reservoir here is both storage and transport, retaining most of its mass, while metering a smaller share toward the centre and a comparable share into young clusters along the ring. It holds its form under pressure shear and weak stirring, and it keeps the inner galaxy supplied on timescales long compared with any
The
single
cluster's
episode
hidden
nearer the
heartbeat.
nucleus. From
Energy
the bright
cycles
body of
through
Centaurus
cavities
A,
and
a
waves,
narrow outflow
keeping the
extends
inner
for
gas
thousands of
alive.
light years on each side of the nucleus,
Light
and
from
widens
old
into
stars
compact
takes a
lobes
billion
embedded in the
years
inner
to
interstellar
arrive,
medium.
but still looks
This is
recent.
the inner jet and its small lobes. The jet carries fast
slow
particles and
collision,
magnetic fields outward
never
along a preferred
ends.
axis that is tilted with respect to the warped dust
They
lane.
call it one
In
galaxy,
high-resolution radio maps,
but its
the jet
light
appears
carries
as a
the
sequence
stories
of
of
bright knots
hundreds.
connected by a fainter spine. In optical and
Gravity's
X-ray
gentle
images,
net.
some of the same knots reappear, which shows that shocks inside the flow heat local material and re-energize particles to emit at higher frequencies. The jet is not a straight, unchanging line. It bends by small angles where it crosses density contrasts, and it brightens where pressure changes force it to readjust its width. These readjustments are reconfinement shocks places where the jet expanding into lower pressure overexpands and then is pushed back, creating stationary compressions. Each compression boosts emissivity and marks the local balance between the jet's internal pressure and the external medium. The sequence of brightenings outlines a gradual deceleration. Speeds near the base are high. Farther out, the jet entrains gas from its
universe
surroundings,
does not
gains
hurry.
mass and slows.
Even
As speed falls, the jet becomes more susceptible to small instabilities that wrinkle its surface and mix it with ambient gas.
The black
Even
hole's
so, the
gravity
flow remains
writes in
collimated on
invisible ink,
kiloparsec
and the
scales
stars
and reaches
obey
the inner lobes
sentences.
where it deposits energy into broader volumes. The two sides of the jet do not look identical. One is brighter and easier to trace. This asymmetry arises from a combination of orientation and environment. When a jet points partly toward the observer, its radiation can be enhanced by motion, while the counterjet can be dimmed. At the same time, the side that crosses a denser part of the interstellar medium suffers more deceleration,
in plasma,
stronger shocks,
how
and more
X-ray
mixing, which
brightness
can change
records the
brightness and
cluster's
structure.
subtle acts of heating
In
and
Centaurus,
motion.
both effects contribute within ranges. The brighter side also shows clearer knots and thin filaments of polarized emission that follow the jet's edge, suggesting a sheath where magnetic fields are stretched and ordered by shear. The jet does work on the gas it meets. Near the dust-laden clouds lie in the path. Where the jet encounters a dense clump, it deflects around it and drives a bow-like compression into the cloud's outer layers. These local shocks heat and ionize gas-producing optical emission lines that align with the radio structure. The lines carry ratios typical of fast shock excitation, in a metal-rich medium with added contributions from young stars where the ring intersects the same region. The shocks accelerate particles along cloud surfaces and create short curved filaments that glow at radio and X-ray wavelengths adjacent to the brightest optical knots. In projection, these filaments appear stitched to the jet by thin bridges, but their motion is dominated by the expanding shock fronts rather than by bulk transport along the jet. The inner lobes are small reservoirs into which the jet empties. They're overpressured at birth and inflate cavities inside the interstellar medium of the central galaxy. As they expand, they sweep up shells of warmer gas and compress dust at their rims. In X-rays, these cavities appear as small depressions flanked by bright edges, where the gas has been compressed and slightly heated. In radio, they shine with synchrotron emission from the plasma that fills them. The rims trace weak shocks moving at a few hundred kilometers per second.
Cavities
These
in
shocks
the glow.
are gentle enough that they do not
The
destroy
mysterious
molecular gas
hollows in the
wholesale,
cluster's X-ray
but they can trigger
brightness.
limited compression in nearby layers, adding structure to the clumpy ring. The result is a mottled inner region where compressed arcs, bright knots and short tongues of emission trace a history of repeated jet cloud encounters. Polarization across the inner lobe shows ordered patterns that wrap around the cavities. This pattern is consistent with magnetic draping, in which field lines in the ambient medium stretch over the advancing lobe and align parallel to its surface. Draping stabilizes the contact against mixing and helps keep lobe edges sharp. It also provides channels along which low-frequency waves can travel into the surrounding gas. These waves carry little energy each, but act over broad angles, distributing the lobe's influence beyond its immediate boundaries. The jet carries not only particles and fields, but also momentum that must be shared with the surrounding medium.
Heat that
Shear
refuses to
layers
cool.
develop along the sides
Why
of the
the
flow where its
cluster's
speed
gas
differs
remains
from the still
hot,
gas.
even as it radiates
In
its
these
energy
layers,
into
turbulence
space.
grows and ambient material is slowly entrained. Entrainment increases the jet's mass flux, lowers its speed, and thickens the rim of mixed plasma. X-ray measurements of the temperature and density near the jet indicate modest increases in turbulence and small amounts of non-thermal pressure support in a sheath that follows the radio spine. The sheath is thin compared with the jet length, but important for energy transfer, because it is where most mixing occurs. A lesser-known detail appears in the patchy Faraday depolarization observed across the inner jet. Depolarization is the reduction of polarized signal by small fluctuations in electron density and magnetic field along the line of sight. In Centaurus, narrow canals of low polarization cross brighter regions.
Somewhere near the rim,
Their presence implies a
star's
foreground
orbit tells a
screen with
secret.
inhomogeneous
There is more mass than
magneto-ionic
meets the
structure
light.
on scales of tens to hundreds of light years. This screen is plausibly the skin of shocked, partially ionized gas that surrounds the jet and inner lobes. Its structure in
Oceans
turn
are
records
poor
where small
archivists.
clouds have been
They
compressed,
recycle
and where
even
the
their
jet's
own
passage has
shells.
changed the local
Where
field.
cold gas goes
The jet's
to
path
vanish.
shows bends that correlate with features in the interstellar medium. One bend appears near the inner edge of the dust
Metallicity
lane where
peaks
gas
toward
density
the heart,
rises, and
a
the effective
fingerprint
sound
of all
speed
the
changes.
stars that live
Another
and
appears at
died
the boundary of an older cavity, where the jet crosses a region already evacuated and then re-enters denser gas. These bends are modest, only a few degrees, and the jet recovers collimation after each deflection. Their presence reinforces the picture that interactions are frequent but not catastrophic. The jet deposit's energy changes direction slightly and continues. Spectra of the brightest knots show power
cluster's
law
hidden
shapes
heartbeat.
across radio through X-ray
Energy
bands,
cycles through
with breaks
cavities
that
and
occur at
waves,
frequencies
keeping the
expected
inner
for
gas
synchrotron
alive.
aging in post-shock regions.
Light
The position
from
of each
old
break
stars
depends on the
takes a
local
billion
magnetic field
years to
strength
arrive,
and on the
but
time
still
since
looks
acceleration.
recent.
The sequence of breaks along the jet supports a pattern in
slow
which particles
collision
are accelerated at
that
discrete
never
shocks
ends.
and then cool as they advect downstream.
They
This
call it
interpretation
one
is
galaxy,
consistent with stationary knots
but its light
that persist
carries
in
the
place
stories
over
of
years
hundreds.
of monitoring in the radio and with X-ray knots that brighten and
Gravity's
fade on
gentle
timescales of years to decades, a sign of rapid energy loss by the highest energy electrons. The inner lobes are not symmetric bubbles. Each shows a brighter edge on one side where motion compresses the rim more strongly against the external medium. On the opposite side, the edge is broader and fainter. Small protrusions extend from the lobe surfaces where the
quiet
jet has
power
pierced the rim
of radios.
and injected fresh plasma, creating secondary features that later merge back into the main volume. Over several million years, the lobes drift outward. Their pressure falls to near that of the surrounding gas, and their rims soften. New lobes expand inside the older ones, and the cycle repeats. The sum over many cycles is a ladder of gentle disturbances that keeps the central atmosphere from
does
cooling
not
in
hurry.
bulk, while leaving its stratification intact. Ionized gas near the jet displays velocity fields with small line splits and broadened profiles. Splits occur where a shock front has passed through a clump and created
and the
two layers
stars
moving at
obey
slightly
the
different
sentences.
speeds. Broadened profiles trace a mix of post-shock flows and unresolved small motions. The measured widths are tens to a few hundreds of kilometers per second, consistent with weak shocks and shears in a dense metal-rich medium. These widths decline away from the jet's path, returning to values set by gravity and the general rotation of the warped disk. Uncertainties in the inner jet region follow from
The history
projection and
written in
resolution.
plasma.
Distinguishing
How X-ray
stationary
brightness
shocks
records
embedded
the
in the
cluster's
flow from
subtle
moving
acts of
features
heating and
requires
motion.
monitoring and careful registration across bands. Separating jet-driven line emission from light produced by young stars along the ring needs spectral diagnostics that can decompose the contributions. Estimating the true three-dimensional bend angles demands models of the underlying density field. Even with these limits, the outline is secure. A narrow relativistic flow emerges from the centre. It brightens at reconfinement shocks. It entrains and slows. It bends where it meets
Earth
denser
breathes
gas.
in strata.
It inflates small lobes that
Weather
press on the
becomes
interstellar
climate.
medium, and it
Climate
launches weak
becomes
shocks
stone.
and waves that shape gas and dust
The
across
Milky
scales
Way
of thousands of
bends
light years.
gently at its rim.
Remaining strictly at this
Not
region, the view holds to the jet and the inner lobes, as they are a collimated spine with knots that mark internal compressions, a sheath
Endurance
where
in
mixing
this
grows
galaxy
compact cavities
means
that carry the
learning how
jet's
to
imprint into
fade
the galaxy,
without
and rims
vanishing.
and filaments that record the exchange with the ambient medium. The pattern persists over many episodes. New knots appear, old ones fade. Small lobes rise, their rims soften. The axis precesses by small amounts, and the interstellar medium responds with arcs, line-bright clouds, and polarized skins that all align with the path of the flow. The inner jet and lobes thus define the immediate channel
The
by which energy
universe
leaves the center
measured
and enters
in
the surrounding
soft
galaxy,
light.
altering it gently but persistently on kiloparsec scales.
Cavities in
Magnetic
the glow.
fields thread Centaurus
The
A from the
mysterious
scale of
hollows
its
in the
outer
cluster's
lobes
X-ray
down through the
brightness.
inner jet and into the warped disk that carries gas and dust across the galaxy. They are not seen directly as lines. They are inferred from how radio light is polarized, from how that polarization rotates as it passes through ionized gas, and from how synchrotron intensity changes where fields are compressed or stretched. Each of these measures supplies a component of the field picture orientation on the sky, the product of field strength and electron density along the line of sight, and the relative order or disorder within a region. Together they show that the fields are coherent over large distances, yet vary with environment and scale. Synchrotron emission is the base tracer. Relativistic electrons spiraling in magnetic fields radiate with electric vectors that are perpendicular to the projected field direction when corrected for the rotation imposed by intervening plasma. Maps of
Why the
polarized
cluster's gas
intensity
remains
therefore
hot,
outline where
even
fields
as it
are ordered and
radiates
where they are
its energy
tangled.
into space.
In the giant lobes, polarization fractions rise over wide areas, a sign that the field has been aligned by expansion and by slow shear during buoyant rise. The vectors curve gently following the lobe edges and internal filaments. In the inner lobes and along the jet, polarization is also strong but more structured with filaments that wrap rims and narrow sheaths along the jet
Invisible
boundary,
architects,
where shear stretches
dark
the
matter
field.
sculpting the
In the
structure of
warped
Virgo,
disk, polarization of
unseen,
background
but
starlight
everywhere.
and of the dust's own thermal emission indicates that grains align with the local magnetic field, and that the field follows the dust lane's curvature over kiloparsec scales. Faraday rotation adds depth. As polarized radio waves pass through ionized gas, the
Somewhere
plane
near
of
the rim,
polarization
a star's
rotates by an
orbit
amount
tells
that
a secret.
scales with the
There is
integral
more
of
mass
electron
than meets the
density
light.
times the magnetic field component along the line of sight. Measuring this rotation at several wavelengths and solving for the rotation measure yields a map of how field direction changes with position and depth.
Oceans are poor
In
archivists.
Centaurus A,
They
the outer
recycle
lobes
even
show
their own
modest, smoothly
shells.
varying rotation
Where
measures,
cold gas
with gradients
goes to
that follow the
vanish.
projected thickness of the group medium. This pattern indicates that most of the rotation arises in the foreground
Metallicity
atmosphere,
peaks toward the
rather
heart,
than within the
a
relativistic
fingerprint of
plasma
all the
itself,
stars that
where
lived
thermal
and
electrons
died
are scarce. In contrast, the inner lobes and jets show strong Apache rotation measures and small-scale swings that point to magneto-ionic skins at their boundaries. These skins created where shocks and mixing partially ionize the ambient gas host fields that are draped and amplified parallel to lobe and jet surfaces. They act as thin, structured screens that both rotate and depolarize the background signal
The
by
cluster's
varying the
hidden
rotation over
heartbeat.
short distances on
Energy
the sky.
cycles through cavities
Ordered
and
fields
waves,
modify
keeping
dynamics
the
in
inner
practical
gas
ways.
alive.
Along the jet field lines, stretched
Light
by
from
shear
old
and
stars
wound by
takes a
rotation,
billion years to
provide
arrive,
tension that resists the
still
growth of
looks
small
recent.
waves on the interface with the surrounding gas.
A
This
slow
suppression
collision
reduces how quickly Kelvin
that never
Helmholtz ripples can
ends.
broaden the jet, and helps it remain collimated over
They call
thousands
it
of light
one
years.
galaxy. But its
Around
light
rising
carries the
cavities, draped
stories of
fields
hundreds.
stabilize the contact and keep edges sharp, limiting
Gravity's
entrainment of
gentle
ambient
net.
gas. In the warped disk fields aligned with dust lanes guide the flow of heat and charged particles along the plane while slowing transport across it. This anisotropy helps cold molecular filaments survive near hot gas, and helps the ring maintain narrow lanes where compression is highest. The strength of the field is estimated
The quiet
indirectly.
power
In
of
radio
radios.
lobes comparing synchrotron brightness with inverse Compton emission, produced when the same electrons scatter low energy. Background photons yields the relative energy densities of particles and magnetic field. In Centaurus A, these comparisons indicate near equipartition within broad uncertainties, meaning that particle and field energies are of similar order across large regions. In the
The
jet
universe
equipartition
does not
estimates
hurry.
and shock models give fields
Even-
strong enough that electrons emitting X-rays lose energy on year-to-decade timescales, consistent with knots that brighten and fade over such
The
intervals.
black hole's gravity
In the
writes
disk,
in invisible
Zeeman
ink.
splitting of specific
stars
lines is not
obey the
detected at the
sentences.
distance, and column densities present, but polarized dust emission implies field strengths comparable to those seen in other massive dusty spirals and warps, with values sufficient to influence cloud support and filament shape. A lesser-known detail lies in rotation measure synthesis, applied to the field of background radio sources seen through the outer lobes. By separating contributions at different
history
effective
written in
Faraday
plasma.
depths,
How
this technique
X-ray
shows
brightness
multiple
records
layers
the
of
cluster's subtle
magneto-ionic
acts of
material between
heating
the
and
observer
motion.
and various parts of the lobes. One layer traces the Milky Way foreground, a second traces the group medium, and in some directions a third thinner layer aligns with the lobe edge. The detection of this edge layer confirms that part of the rotation arises in the immediate environment of the lobe, and not only in the broader atmosphere, strengthening the case for magnetic draping as a recurring feature. Magnetic fields also shape how energy spreads as waves. Alphen waves in magnetosonic modes travel
Earth
along and
breathes
across
in
field
strata,
lines,
tail.
carrying small disturbances
becomes
launched by
climate.
shocks at the jet
Climate
base
becomes
and by
stone.
readjustments as cavities expand.
The Milky
In
Way
a weakly
bends
collisional
gently
high-temperature
at its
plasma,
rim.
these waves damp
God
over long distances through a mix of viscosity conduction along field lines and small plasma instabilities. The damping converts mechanical
Endurance
energy into
in
heat,
this
gradually
galaxy
helping to offset
means
cooling in the
learning
inner
how to
atmosphere
fade
without erasing
without
stratification.
vanishing.
The presence of ordered fields helps these waves propagate coherently across hundreds of light years in the inner regions and across many thousands of light years in the outer lobes before they fade into the background. Within the warped disk, fields influence how clouds collapse. In diffuse layers, magnetic pressure and tension add to thermal pressure and turbulence to resist gravity, raising the threshold, column density needed for bound core formation. Where lanes intersect and compression is high, field lines can bend and concentrate, guiding material into filaments while allowing ambipolar
Cavities
diffusion
in
and
the glow.
reconnection in dense cores to
The
reduce
mysterious
magnetic
hollows
support
in the
and permit
cluster's
collapse.
X-ray brightness.
Observationally, this balance appears as star formation concentrated near convergences with many filaments, remaining stable elsewhere despite high overall gas content. The influence of fields on cosmic rays is twofold. They confine relativistic particles within the lobes and along the jet, lengthening the time these particles remain close to their sources and smoothing gradients in particle density. They also set the rate at which any cosmic ray population can stream into the surrounding gas. If streaming occurs, wave damping can heat the ambient medium in thin boundary layers. Gamma ray limits on hadronic cosmic rays suggest that this heating is not dominant on group scales, yet the ordered fields and thin skins around inner lobes leave room for a modest contribution to the local energy budget near those boundaries. Polarization fractions reveal where order is high and where turbulence
that
is strong.
refuses to cool.
In the outer lobes, high
Why the
fractions over
cluster's
large
gas
patches
remains
imply
hot,
that turbulence
even as
is
it
low,
radiates its
and that
energy
expansion
into
has
space.
sorted field directions. In the inner lobes and jet lower fractions and rapid spatial changes indicate tangled fields in shear layers and at shock sites. In the disk, optical polarization of starlight peaks at intermediate extinctions and declines, where columns are either too high or too low. These trends match expectations for grain alignment and for the dilution of polarization
Invisible
by mixed field
architects,
orientations
dark
within the beam.
matter sculpting the structure
Uncertainties
of
in
Virgo,
magnetic
unseen,
maps arise from
but
projection
everywhere.
beam averaging and the unknown three-dimensional arrangement of emitting and rotating layers. Rotation measures combine field and electron density. Disentangling the two requires independent constraints on the thermal gas. Depolarization canals can mimic field
Somewhere near
reversals
the rim,
when they
a
instead
star's
mark
orbit
small-scale
tells a secret.
structure in the screen.
There is more mass
Equiposition
than meets
relies
the
on
light.
assumptions about the electron spectrum and filling factor. Even with these caveats, the consistent alignment of polarization with lobe rims, jet sheaths, and dust lanes builds a coherent picture the
Oceans
field
are
is
poor
ordered by flow and
archivists.
geometry.
They
And
recycle
it feeds
even
back
their
on
own
that flow by
shells.
stabilizing
Where cold gas
interfaces, guiding
goes to
transport, and
vanish.
channeling waves. The role of fields changes with radius. In the group medium, they're
Metallicity
too weak to
peaks toward
support the
the
gas
heart,
against
a
gravity,
fingerprint
but
of
strong
all
enough
the
to affect
stars
heat
that
flow and
lived
wave damping.
and died here.
In the lobes, they share energy with particles and maintain structure over long times, allowing buoyant evolution without rapid mixing. In the jet, they shape collimation and shock spacing and carry part of the momentum flux. In the disk, they support diffuse layers, set filament widths, and organize photodissociation skins around molecular cores. Across all scales, they provide memory once
The
aligned
cluster's
by a
hidden
flow fields
heartbeat.
remain ordered,
Energy
until a new
cycles
flow
through
unties them,
cavities and
which is why
waves,
fossil
keeping
rims
the
and old
inner
cavity
gas
edges can
alive.
still carry distinct polarization
Light
long
from
after their
old
brightness
stars
fades,
takes a billion years
remaining
to arrive,
strictly at this region
but still
and not
looks
stepping
recent.
inward to the accretion flow. The view ends on magnetism as a
slow
structural
collision
component.
that
Polarization
never ends.
vectors follow rims and lanes. Rotation measures
They call
separate
it
foreground
one
atmosphere
galaxy,
from thin-edge screens.
But its light
Field strength
carries the
estimates place
stories of
particles and
hundreds.
fields in rough balance over wide areas. Suppressed
Gravity's
instabilities keep
gentle
contact sharp. Anisotropic transport preserves cold cores. Weak waves travel along organized paths. The magnetic field is not the main source of gravity or pressure. but it is the framework that shapes how energy and matter move through Centaurus A, from the lobes to the jet to the warped disk, keeping order in a system still settling from a recent encounter. At the centre of Centaurus, a black hole of tens of millions of solar masses sets the smallest gravitational scale. Stars in the innermost arc seconds move with dispersions that rise toward this point, and gas closer still responds on orbits that curve faster than in any other part of the galaxy. The dust lane hides much of the region at optical wavelengths, yet other bands see through or around the screen. In the near-infrared, a compact peak in light marks the nucleus. In hard X-rays, a variable source brightens and fades on times as short as days to weeks, which indicates a region no larger than light can cross in that span. In radio, the base of the jet stands nearly atop the same position, with a core that brightens when outflow strengthens. Taken together, these signs fix the presence of a central engine that draws in matter and sends out energy both as radiation and as a narrow directed flow. Gas reaches the nucleus by several routes. The warped kiloparsec ring narrows into a set of streamers that carry cold molecular clouds across the inner few hundred light years. Their speeds differ from pure circular motion by small amounts in the sense expected for inward drift along tilted orbits. Closer in dispersion grows, and ordered rotation takes a larger share of support, as if the clouds have begun to share angular momentum and to settle toward a thicker clumpy disk. At still smaller radii on scales too fine to map directly in this nearby system, the flow becomes continuous. Turbulence, magnetic stress, and small gravitational torques move angular momentum outward in pieces while
Earth
mass drifts
breathes
inward.
in strata,
The structure is layered rather
Weather
than a
becomes
single thin
climate.
sheet.
Climate
A warm,
becomes
geometrically
stone.
thick component surrounds a denser equatorial layer.
The Milky Way
Above and below it, a
bends
dilute
gently
corona
at
carries
its
hot
rim.
electrons that scatter photons to higher energies. Radiation from the innermost orbits carries a power law shape in X-rays that hardens and softens as the supply changes.
Endurance
An iron line
in
near a
this
fixed energy
galaxy
appears and
means
deepens with
learning how
time
to
when
fade
reflection from
without
dense
vanishing.
circumnuclear gas strengthens. The line carries a small width that points to a radius larger than the last stable orbit, which means the reflecting layer lies beyond the hottest part of the flow. Variability in the continuum without immediate change in the line confirms that some of the reprocessing material sits far enough away that light travel time dilutes the response. These timing relations help place pieces of the inner geometry without requiring a direct image. The black hole launches jets which signals that magnetic fields near the event horizon reach organised strong configurations. Inflows that bring in net magnetic flux can saturate the inner region, with field lines that thread the rotating gas in the hole itself. As the inner flow turns, it winds the field and drives pointing flux outward. The power in this channel depends on spin on the magnetic flux near the horizon and on the rate at which the outer flow feeds the inner ring. None of these parameters is measured directly in Centaurus A, yet the steady presence of a collimated jet and the energy it carries on kiloparsec scales show that the combination is sufficient to maintain mechanical output over many cycles. Radiatively, the nucleus sits in a regime where mechanical work dominates the long-term energy ledger. The spectral energy distribution lacks the strong blue bump typical of bright thin disks around more luminous nuclei. Instead, the continuum rises from radio through infrared and into X-rays, with a shape that points to a radiatively inefficient
Heat
inner
that
flow,
refuses to
one in
cool.
which much of the heat
Why the
remains in
cluster's
the
gas
ions,
remains
or is
hot,
advected
even as it
inward,
radiates its
rather than
energy
being
into
radiated
space.
promptly. In such a state, small changes in supply can swing the balance between light and mechanical work, without changing the total power by large factors, which matches the observation that radio lobes and inner cavities grow steadily, even while the X-ray core flickers. The immediate environment is dusty and clumpy. Mid-infrared emission shows warm grains in a compact distribution that surrounds the nucleus and aligns with the inner warp.
Sculpting the structure
This
of
dust
Virgo,
absorbs a share of the
unseen,
optical and
but
ultraviolet
everywhere.
light from near the black hole and re-emits it at longer wavelengths. The patchy screen explains why some sightlines see stronger hard X-rays than soft, and why neutral columns rise and fall with time. Changes in column over months to years imply clouds crossing
Somewhere
the
near
line
the
of
rim,
sight at radii,
a star's orbit
where
tells a
orbital
secret.
periods are of similar
There
length.
is more mass
The
than
crossing
meets the
speeds
light.
inferred from these times place the clouds within a few light years to a few tens of light years of the core, consistent with a clumpy molecular torus, or thick disk that shares the warp's orientation.
Oceans are poor
Gas supply to the
archivists.
engine is mixed
They
in
recycle
phase.
even their own
Hot
shells.
plasma from the inner
Where
atmosphere
cold
can drift
gas
inward
goes
along
to
nearly
vanish.
spherical paths where pressure and gravity balance, contributing a slow, steady background.
Metallicity peaks
Cold
toward
clouds
the
from the
heart,
molecular
a
network
fingerprint
arrive
of
as
all the
discrete
stars
parcels that can
lived
lose
and
angular
died here.
momentum through collisions and tides, and then merge into the inner flow. When the cold channel strengthens, the nucleus brightens across bands, and the jet can harden close to the base. When it weakens, the flow falls back toward the hot mode, and mechanical power can persist with modest radiative change. These shifts occur within ranges. The circumnuclear reservoir smooths the outer
The
variability,
cluster's hidden
and the
heartbeat.
thick inner flow buffers
Energy
fast
cycles
swings
through
by
cavities
storing and
and
releasing
waves,
heat on
keeping
dynamical
the inner
times.
gas alive.
A lesser known detail appears in the
Light
way
from
low-frequency
old
radio
stars
emission
takes
from
a
the core
billion
sometimes
years to
rises,
arrive,
without an
but
immediate
still looks
counterpart at
recent.
higher frequencies. This behaviour fits small injections of
slow
fresh
collision
relativistic plasma
that
into
never
the base of the jet, which then self-absorbs at higher frequencies.
They call it
until
one
expansion
galaxy,
lowers the opacity.
but its light
The
carries
delay
the
between
stories of
bands
hundreds.
constrains the size and expansion speed of the ejection,
Gravity's
placing it within light
gentle net.
weeks of the black hole, and confirming that knot formation begins very close to the engine. Feedback from the nucleus reaches outward even before the jet becomes narrow. Weak shocks and sound waves launched by readjustments in the inner pressure field propagate into the surrounding interstellar medium. Their spacing in surface brightness maps corresponds to intervals of a few million years,
quiet power
consistent with cycles in which
radios.
accretion field build-up and ejection repeat. Each episode inflates compact cavities that later rise as already traced at larger radii. In this way, the accretion flow writes its own timing into the atmosphere without requiring that radiative output be high. The mass of the black hole is measured by modelling stellar and gas motions near the centre, with the dust lane's extinction accounted for.
The universe does
Results
not hurry.
converge on a value in the tens of
Even-
millions of solar masses, with ranges set by the unresolved inner geometry and by the contribution of the young stellar component to the
The
potential.
black hole's gravity.
This mass
writes
matches the
in
scale
invisible
implied by the
ink,
width of
and
broad
the
nuclear
stars
lines
obey
seen in
the
polarized light,
sentences.
and by correlations between black hole mass and stellar velocity dispersion in massive galaxies. The agreement ties the nucleus of Centaurus A to the same family as other nearby radio galaxies, even though its immediate environment is shaped by a recent merger. Uncertainties remain in the exact partition of inflow between cold and hot phases in the spin of the black hole and in the amount of magnetic flux
plasma,
accumulated near the
how
horizon.
X-ray brightness records
These parameters
the
matter
cluster's
for the
subtle
ratio
acts
of jet
heating
power to
and motion.
radiative power, and for the detailed shape of the inner spectrum. Observations at higher angular resolution across millimeter wavelengths, where absorption by dust and plasma is lower, continue to sharpen these estimates by resolving the region where the jet turns optically thin and by measuring core sizes that change with frequency. Even with unknowns, the outline is steady. A clumpy warped reservoir narrows into a thick magnetized inner flow. That flow radiates modestly, launches a jet, and varies in X-rays on short
breathes in
times
strata
that mark
and
the
decay.
scale of the deepest
Weather
potential.
becomes
A
climate.
dusty molecular
Climate
screen surrounds the
becomes
engine
stone.
and changes the view with passing clouds.
The Milky
Mechanical
Way
output couples to the
bends
interstellar
gently
medium
at its
through
rim.
compact cavities, shocks and waves, while the larger jet carries energy to kiloparsec scales and beyond. Remaining strictly within this radius, the description ends at the place where inflow
in
meets
this
horizon
galaxy
and outflow
means learning
begins.
how to fade.
The region is small by
without
galactic
vanishing.
measures, yet it governs the cycle seen in the inner lobes and in the group atmosphere. Gas arrives by slow drift and by clumpy delivery fields gather and launch power and radiation from the core mark's changes in supply. The engine does not empty the reservoir or flood the galaxy. It holds the centre in a state where cooling does not run away, and where the warped disk continues to feed stars and in measured shares the whole itself. Energy
universe
released at the center moves
measured
through Centaurus
in
A in
soft
several channels
light.
and returns to the surrounding gas as heat and motion. The
Cavities
narrow
in the
jet
glow.
supplies a directed flow
The
that inflates
mysterious
compact
hollows in the
lobes,
cluster's
while
X-ray
weaker
brightness.
shocks and sound waves carry smaller pressure changes across larger angles. The result is feedback that offsets cooling in the inner atmosphere and moderates how gas settles toward the nucleus. This exchange is clearest where the jet has produced cavities in X-ray maps of the interstellar medium. The cavities displace denser gas and are rimmed by shells, where compression has raised brightness and temperature slightly. The pressure that confines a cavity multiplied by its volume gives a first estimate of the energy needed to inflate it. Adding a modest factor for work done as the cavity rises and expands brings the total to values that, when divided by the time since each cavity formed, yield a mechanical power comparable to the radiative losses from hot gas in the same region. The conclusion is careful and sustained mechanical output balances a substantial share of cooling over long intervals without a
that
single
refuses to
episode
cool.
dominating the total.
Why the cluster's
Waves
gas
spread
remains
this power
hot
beyond the
even
rims.
as it radiates its
Faint
energy
nested
into
ripples
space.
curve through the hot gas on scales of thousands of light years. Their pattern and small amplitude match weak shocks near the inner lobes that fade into sound as they travel. Each crest carries a little energy that converts into heat through viscosity and small plasma effects. Many crests together smooth the pressure field and raise entropy gently.
Invisible
Because the spacing of ripples corresponds to a few million years, the atmosphere sees a sequence of small pushes rather than a single strong impulse. These pushes are enough to slow the inward drift of low entropy gas and to keep temperature and density gradients near their observed forms. The gas answers in texture rather than in bulk motion. Rims thicken where waves cross or where a cavity is pressed
Somewhere
most
near the
recently.
rim, a star's
Elsewhere,
orbit tells a
contact
secret.
edges appear where
There
cooler
is more
layers slide
mass than
past
meets
warmer
the
ones
light.
under the same pressure. Magnetic draping along both rims and edges stabilizes the interfaces and reduces mixing. Stabilized contacts allow heat to move mainly along field lines, not
Oceans
across
are
them,
poor
which
archivists.
preserves temperature
They
contrast while
recycle
still
even
letting
their own
waves share
shells.
energy over wide angles.
Where cold gas
The
goes
effect
to
is
vanish.
to distribute heat broadly while keeping the multi-phase structure intact. Star formation inside the dust lane
Metallicity
responds to
peaks
this
toward the
environment.
heart. a
Compressions from
fingerprint
weak
of all the
shocks can raise
stars
pressure
that lived
locally
and
and
died
collect
here.
gas into denser lanes. Yet the same pressure and gentle heating at cloud surfaces prevent rapid runaway collapse. Measured across the ring star formation proceeds at a moderate pace, converting only a small fraction of molecular gas per local orbit. This rate sits below what would be expected if cooling acted without feedback. The difference is the mechanical work from the nucleus,
The cluster's
which adds
hidden
to gravity
heartbeat.
and shear,
Energy
in
cycles
setting the
through
balance between
cavities and
compressed
waves,
zones that form
keeping the
clusters
inner gas
and diffuse
alive.
stretches that remain stable.
Light
Chemical
from old
signatures
stars
record
takes
this
a
balance.
billion years to arrive.
Heavy elements in the hot
but
phase
still
supplied
looks
by
recent.
past generations of stars in the bulge and by recent clusters in the ring
slow
make cooling
collision
more efficient at a given
that
temperature.
never ends.
Regions with higher abundance would cool faster without heating.
They call it one galaxy.
In Centaurus,
But its
abundance
light
is
carries
elevated
the
toward the
stories of
center,
hundreds.
yet widespread rapid cooling is not observed.
Gravity's
The presence of
gentle
cavities,
net.
ripples, and rims explains the difference. Heat arrives where it is needed most often, and metals are lifted along cavity flanks to slightly larger radii, where they mix, slowly broadening the zone in which cooling is efficient, but reducing the peak rate at any one place. A lesser-known detail sits in the faint older cavities that have drifted outward and softened into low-contrast depressions. Their rims fade and their radio emission dims with time, yet their displacement remains present as a gentle change in pressure. Counting these ghost cavities increases the integrated energy budget beyond what the youngest features alone imply, and lengthens the interval over which feedback can be shown to have operated. The sum over many such events matches the long-lived stability of the hot
universe
atmosphere
does
against
not
bulk
hurry.
collapse.
Even-
Energy transfer is not confined to hot gas. The jet and small lobes also touch the warm and cold phases. Along the edges of
black
inner
hole's
cavities,
gravity
thin layers of
writes in
ionized
invisible
gas
ink,
brighten where
and the
compression
stars
and
obey
mild
the
shocks raise
sentences.
densities and temperatures. In nearby molecular lanes, pressure rises modestly, line widths broaden, and some clumps gain mass by condensing mixed gas from their skins. These changes are local and limited. They show that feedback shapes the conditions for star formation, without either quenching it entirely or igniting a single brief starburst across the ring. The mechanical channel dominates the ledger at these radii, yet radiation from the nucleus contributes in specific ways. Hard X-rays from the inner flow penetrate dusty screens and heat small grains that re-emit in the mid-infrared. Ultraviolet photons from young stars in the ring add to this field. Together they maintain photodissociation layers on cloud surfaces, where cooling lines carry energy away efficiently. The presence of these layers allows the system to shed heat where it is deposited mechanically, and helps prevent excessive accumulation of very cold gas that would otherwise fall inward quickly. The partition of inflow among outcomes follows from this regulation. A share of gas remains hot and returns to higher entropy through mixing and wave damping. A second share becomes part of the molecular reservoir and forms stars at a steady moderate rate. A smaller share reaches the nucleus and powers the jet. These fractions vary within ranges as cycles of activity strengthen or ease, but the totals over many cycles close near balance when mechanical power is integrated over the volumes where cooling would otherwise proceed. Uncertainties remain in detail. The effective viscosity of the hot gas, which sets how quickly waves damp, is not measured directly and may vary with radius. The suppression of thermal conduction across tangled magnetic fields is estimated from sharpness of edges and from comparisons with models, yet small instabilities can change transport locally. The fraction of jet power that turns into cavity work shocks and sound versus the fraction that leaves as cosmic rays or magnetic energy is also not fixed by observation alone and must be inferred from the absence of strong gamma-ray signatures and from pressure balance. Even with these unknowns, the broad accounting is robust because several independent measures, cavity energetics, ripple spacing, X-ray cooling rates, and star formation rates agree within comfortable limits. A practical result of this balance is the persistence of the observed profiles. Density in the hot phase declines smoothly with radius. Temperature rises from the dust lane outward, before easing at larger scales. Entropy increases monotonically. If feedback were too weak, central entropy would drop further and colder gas would be far more common. If feedback were too strong, cavities and shocks would be broader, and the multiphase gas would be rare. The present state sits between these extremes. The inner atmosphere is bright but not collapsing. The ring forms stars but does not exhaust its supply. The jet and inner lobes repeat without breaking the disk. The group medium beyond the galaxy shows only gentle disturbances where the outer radio structures meet it. The geometry of the warped disk and the traxial stellar potential helps maintain this balance by spreading compression around the ring and by moving intersections of lanes with time. As precession shifts where lanes converge, different segments take turns forming clusters, and no single sector drains the reservoir. At the same time, small changes in jet direction spread cavity work across several angles, further averaging the heating.
Sculpting the structure
A lesser
of
known
Virgo,
detail lies in the correlation
but
between
everywhere.
the width of inner ripples and the electron mean free path in the hot gas. Where widths exceed several times that path, classical viscosity can account for damping. Where widths are smaller, additional microphysical processes must be present. In Centaurus, a ripple widths
Somewhere
and
near the
contrasts
rim,
suggest
a
that both
star's orbit
classical
tells
and
a
plasma
secret.
effects
There
contribute,
is more mass than
which is
meets the light.
consistent with the presence of ordered magnetic fields that guide transport. Remaining strictly within this scale, the view ends with the cycle in operation. Gas cools from
Oceans
the hot phase
are poor
enough to build
archivists.
reservoirs and stars,
They
but not enough to
recycle
collapse
even
in
their own
bulk.
shelves.
The nuclear
Where
supplies
cold
mechanical
gas
energy
goes
that
to
inflates
vanish.
cavities, launches weak shocks and sends waves outward. Magnetic fields stabilize
Metallicity peaks
interfaces
toward
and guide
the
heat
heart,
along ordered
a
paths.
fingerprint of all the
Metals
stars
lifted by
that
bubbles
lived
broaden
and
the
died
region in
here.
which cooling is efficient, even as waves add heat back. Over many episodes, the sums stay near balance, and the structure of the inner galaxy and its atmosphere remains layered bright and slowly evolving. Time in Centaurus A is written in layers that slow with radius. The outer halo keeps records that last for hundreds of millions of years, while the inner atmosphere writes and erases finer lines on
The
times of
cluster's
millions
hidden
of years.
heartbeat.
The
Energy
sequence
cycles through
begins in the
cavities and
outskirts with
waves,
shells and
keeping
streams
the
that
inner
curve
gas
around the
alive.
galaxy. Their spacing
Light
and brightness
from old
point to a
stars
merger that
takes
is
a
recent on
billion years
galactic
to arrive,
scales.
but still
Stars in
looks
elongated
recent.
orbits crowd where they turn drawing arcs, whose separation
slow
shrink
collision
inward because inner paths
that
complete
never
more
ends.
oscillations. Counting these wraps and matching their
They call
distances
it
to
one
typical
galaxy,
orbital times in the combined
but its
potential
light
returned
carries the
ages of a
stories
few
of
hundred
hundreds.
million years for the first pass and somewhat less for subsequent
Gravity's
layers.
gentle net.
This is the slow ledger, an encounter, places stars on eccentric tracks, and those tracks fold into caustics that fade gradually but persist long enough to be mapped. Gas carries a connected clock. The neutral hydrogen ring surrounding the galaxy is warped and precessing. Tilt and line of nodes change smoothly with radius, and the rate of that change encodes the time since the ring was deposited. Models that follow tilted rings through a triaxial field point to settling times of a few 100 million years as well consistent with the shell ages. The match is not exact at every radius, because gas dissipates. While stars do not yet, the broad agreement places the birth of both structures in the same era. A lesser-known detail emerges in the gentle
universe
flaring of the
does
ring.
not hurry.
The vertical thickness increases toward larger radii, in a way that fits differential precession acting, for long enough to smear planes but not long enough to erase the
The
warp.
black hole's gravity
This too
writes
ties the
in
ring to a
invisible
middle age
ink,
between the fresh
and
shock
the
of
stars
arrival
obey
and the
the
distant future of
sentences.
complete alignment. Moving inward, the dust lane gives a faster cadence. Its clumps and folds drift under shear and precession. Over many tens of millions of years, knots shift by appreciable angles around the centre, and short lanes lengthen or thin as orbits slide past one another. Radiative transfer models that reproduce present asymmetries imply a geometry that continues to turn slowly,
Plasma.
and this turning
How
rate
X-ray
fits an
brightness
age still
records the
younger than the
cluster's
halo
subtle
shells,
acts of
but
heating
older than the
and
newer
motion.
star clusters in the ring. The ring of active star formation marks an even quicker pace. Cluster ages along its length span from only a few million years to a few tens of millions of years. The spread shows that formation has continued since the dust lane and molecular network settled enough to compress. The drift of ages around the ring follows gas flow. Older knots sit downstream of current peaks in pressure where lanes intersect. Younger knots sit at today's convergences. The rate of star formation summed across the ring
breathes in
remains in the
strata
range of a
decay.
few solar masses each
Weather
year. Over these
becomes
spans,
climate.
a steady output for a
Climate
system of this
becomes
mass.
stone.
The jet and inner lobes add the shortest
The Milky
repeating
Way
signals on
bends
galactic scales.
gently at its
Compact
rim.
cavities near the centre, and faint nested ripples in the surrounding hot gas appear at intervals of a few million years. The spacing of ripples records weak shocks launched
Endurance
when inner pressure
in this
readjusts
galaxy
and when jets
means
brighten or
learning how to
contract.
fade.
As the
without
wave crests
vanishing.
travel outward and fade into sound, the next set begins producing a ladder of crests, whose separation gives a reliable clock. The size and position of inner cavities carry the same timing. By way of buoyant rise, a bubble needs roughly its own diameter's travel time to climb, and the sequence of bubbles at increasing radii arranges past episodes into an ordered set. The outer radio lobes integrate these many cycles.
A universe
Their spectral steepening
measured
from higher to lower
in
frequencies
soft
implies
light.
aging of tens of millions to perhaps 100 million years across different
Cavities
patches,
in the glow.
a sum over multiple
The
replenishment
mysterious
phases
hollows in
rather
the
than a
cluster's
single brief
X-ray
event.
brightness.
Low-frequency bridges between inner and outer structures show that channels have reopened more than once, allowing fresh plasma to reach older volumes and extend their lives. Against these clocks sits the nucleus. X-ray variations occur on days to weeks, a direct measure of the light-crossing size of the region that changes. Radio changes at low frequencies can lag higher bands by weeks to months. The self-absorbed knots expand and become transparent, fixing the origin of new features within light weeks of the black hole. These rapid signals are filtered by the circumnuclear reservoir and by the inner flow, so that the event that starts in days becomes a lobe that fills in millions of years. The merger history and activity sequence therefore align as a nested set. A gas-rich companion arrived a few 100 million years ago and deposited stars into shells, gas
Heat
into a
that
warped ring,
refuses to cool.
and dust into a
Why
thick
the cluster's
lane.
gas
As
remains
the ring
hot,
precessed,
even as it radiates its
streams
energy
crossed,
into
pressure
space.
peaks formed and migrated, lighting a kiloparsec belt of new clusters whose ages now trail around the disk. In parallel inflow along the warped plane fed the center intermittently. Each period of stronger supply built inner cavities and sent weak shocks outward. The sum of many such periods inflated and refreshed the giant lobes that still
Invisible
rise through the group
architects.
medium.
Dark matter
The times
sculpting
match
the
within
structure
broad
of Virgo,
tolerances shells
unseen,
older than the
but
warp at small
everywhere.
radii, the warp older than most clusters, clusters older than the freshest cavities and cavities, older than the wave crests now near the edge of the inner atmosphere. Uncertainties remain in each step. Shell ages depend on potential shape and viewing angle.
Somewhere near the rim,
Ring
a
settling
star's
depends on
orbit tells a
unknowns in
secret.
dissipation
There
and
is
in
more
exact
mass than meets the
triaxiality.
light.
Cluster ages depend on extinction corrections and on assumptions about stellar mass distributions. Jet duty cycles inferred from cavities depend on buoyant speeds
Oceans
and
of poor
projection.
archivists.
Even so,
They
the
recycle
pieces hold
even
together
their own
because each is
shells.
anchored by an
Where
independent measure.
cold gas goes to
Kinematics for
vanish.
shells and ring spectra, for clusters and lobes, geometry and pressure for cavities and
Metallicity
ripples.
peaks
And
toward
because
the
their
heart,
relative order
a
is set by
fingerprint
simple
of all
physics
the stars
orbits
that
that
lived
take hundreds
and
of
died
millions of
here.
years to wrap disks that precess more quickly, clusters that age in tens of millions of years, and waves that cross in millions. Three ironies remain quiet, only took a collision to leave behind long-lived order in shells and a slowly processing ring, both of which now read as calm structure. Only took weak shocks to write a durable heating record in an atmosphere that could otherwise cool quickly
The
each
cluster's
crest,
hidden heart.
carrying little energy,
Energy
and yet in
cycles through
sequence
cavities
enough.
and waves.
Only took
keeping the
short
inner
irregular
gas
flares
alive.
near the horizon to power lobes
Light
that drift
from
for
old
tens of
stars
millions
takes a
of years
billion
far
years to
beyond the
arrive,
times that first
but
lit them.
still looks
The
recent.
gentle mystery stays in the precise timing between the rise of
slow
star formation along the
that
ring
never
and the
ends.
onset of the present jet cycle. Whether a particular
They call
pass
it
of lanes
one
seeded
galaxy,
the inflow that fed the current
but its
engine,
light
or
carries
whether the two
stories
tracks
of
only share the
hundreds.
same broad supply is not fixed by present maps. The offsets are
Gravity's
small,
gentle net.
the clocks overlap and the central reservoir smooths the link. Another uncertainty lies in the rate at which the ring will align with the inner galaxy. Precession will continue to move convergences changing where clusters form and how mass drifts inward. The pace of this movement sets how long the current belt remains distinct. Even with such open points, the timeline
quiet
reads
power
simply at each
of
radius.
radios.
The outer halo keeps the merger in wide arcs whose gaps shrink with time. The ring carries a procession of young clusters that circle with the gas. The inner atmosphere records cycles of bubbles and ripples that keep pace with supply. The giant lobes store many episodes. The nucleus flickers in days and writes in millions of years. The sequence remains outer to
The
inner, slow
universe
to
does
fast
not
without
hurry.
need to step beyond the present
Even-
radii. It ends with the clocks in place, each keeping time appropriate to its scale, and each setting the condition for the next smaller region. The inner region of Centaurus A presents a layered arrangement that holds steady while small parts move. Closest to the nucleus, a compact core shines in hard X-rays and at millimeter and radio wavelengths. Its size is set by the short times on which it varies, and by the frequency at which the jet base turns transparent. Around this core lies a clumpy screen of dust and molecular gas that changes the view with passing clouds. Farther out, ionized skins and warm atomic layers wrap the colder lanes of the warped disk.
Plasma. How
Beyond them,
X-ray
the
brightness
hot
records
interstellar
the
medium
cluster's
carries
subtle
weak
acts of
waves
heating
and keeps
motion.
pressure gradients that rise toward the center. The jet threads these layers bright near its origin, and then segmented by internal shocks as it crosses changes in external pressure. The picture is not a single surface. It is a stack of media held by gravity and shaped by supply, each phase exchanging heat and momentum with neighbours, without erasing its own identity. The present jet axis is tilted with respect to the dust lane, and the major axis of the stellar body. Near the base, the jet is narrow
Earth
and bright,
breathes
its
in
knots
strata
marking
and decay.
reconfinement, where the
Weather
internal
becomes
pressure
climate.
matches the surroundings and
Climate becomes
overshoots.
stone.
Farther out, the flow widens into compact lobes
The
that
Milky
press on the
Way
interstellar
bends
medium and lift
gently
weak
at its
shocks
rim.
into the hot gas.
Got rugged.
Polarization maps show fields that follow the jet edges, and wrap the lobe rims a sign that draping stabilizes contacts and channels small disturbances
Endurance
outward.
in this
The
galaxy
counterjet is fainter
means
shaped
learning
by
how to
orientation
fade
and by the
without
different columns it
vanishing.
crosses. Both sides remain collimated over kiloparsec scales and feed the inner cavities, whose rims appear in X-rays as shallow arcs. The dust lane continues to obscure the central band in optical light, yet near infrared, and radio bands resolve structure across it. Cold lanes curve with the warp and converge into the inner few hundred light-years, where clumps and short streams appear in molecular lines. Their velocities trace rotation with small drifts that point inward, and their dispersions exceed thermal widths, a sign of turbulence
Cavities
and
in the
unresolved
globe.
substructure.
The mysterious
Closer to the
hollows
centre,
in
the gas
cluster's
becomes
X-ray
thicker and more
brightness.
continuous. The warm component fills a larger fraction of volume and carries electrons that scatter photons to higher energies. The arrangement admits both hot and cold supply. Hot gas from the inner atmosphere drifts inward slowly, while cold parcels from the warped disk arrive in episodes, lose angular momentum through collisions and tides, and blend into the inner flow. Radiation from the core is modest compared with mechanical work. The spectrum lacks a strong blue bump. Hard X-rays vary on days to weeks, and mark changes deep in the potential well. A neutral column measured along the line of sight rises and falls with time, which points to transits by individual clouds, in a clumpy screen at scales of light-years to tens of light-years. Mid-infrared emission from warm dust surrounds the nucleus and aligns with the inner warp
Heat that
reprocessing part of the
refuses to
light from
cool.
smaller radii.
Why the cluster's gas
These
remains
pieces together
hot,
make a
even as it
nucleus in
radiates
which
its
mechanical
energy into
output
space.
dominates long-term energy transfer, while radiative output carries the immediate signature of supply. The hot interstellar medium near the centre remains stratified. Pressure increases inward. Entropy falls to a floor, but does not reach values that would allow bulk rapid condensation. Weak shocks from recent activity raise temperature by small factors along thin fronts, and then
Invisible
fade into
architects,
sound waves that
dark
travel
matter
outward
sculpting
and
the
dissipate
structure of
gradually.
Virgo, unseen,
The spacing
but
of visible
everywhere.
ripples indicates episodes separated by a few million years. Together with small nested cavities that drift from the nucleus with buoyant speeds, these ripples fill the inner tens of thousands of light years with gentle time markers that match the power needed to offset cooling. The star-forming
Somewhere
ring
near the
inside
rim,
the dust
a
lane
star's
continues
orbit
at a
tells
moderate
secret.
pace.
There is
Young
more
clusters
mass
gather
than
where
meets the
lanes
light.
intersect and where pressure is highest, marking regions influenced both by the warp and by low amplitude compression from the latest inner events. Line ratios in warm gas confirm
Oceans
high
of poor
abundances of heavy
archivists.
elements
They
that
recycle
shorten
even
cooling
their own
times in narrow
shells.
skins
Where
without
cold
tipping the
gas
balance
goes
toward
to
runaway
vanish.
collapse. On average, the ring turns only a small share of its molecular mass into stars per
Metallicity
orbit,
peaks
and
towards
leaves a large
haunt,
reservoir in
a
clumps and
fingerprint of
filaments
all
that
the
continue to
stars
circle
that
and
lived
precess.
and died here.
The chemical and kinematic continuity from molecular lanes to ionized skins and then to hot gas remains clear in maps that join bands. Heavy elements enriched by older stellar populations in the bulge and by recent clusters in the ring appear in both warm and hot phases near the centre. Abundance ridges align with paths where inner cavities have lifted gas. Velocity fields show modest shear where the
cluster's
jet
hidden
has crossed
heartbeat.
dense clumps and
Energy
broader line
cycles through
widths and thin
cavities and
shells around the
waves,
compact
keeping
lobes.
the inner gas alive.
None of these contrast breaks the underlying
Light from old
stratification.
stars
They
takes
add
a
relief
billion
to a
years
stable
to
background.
arrive, but still
A lesser
looks
known
recent.
detail at the present epoch is the slight offset between the brightness
slow
peak of the hard
collision
X-ray core
that
and the
never
centroid of the
ends.
innermost radio knots when measured over intervals of
They call
months
it
to years.
one galaxy,
The offset is small
but
and
its light
falls within
carries
errors
the
on short
stories of
baselines.
hundreds.
Yet over longer monitoring it repeats consistent with
Gravity's
knots
gentle net.
that brighten downstream after a brief delay set by expansion and by the time needed for newly accelerated electrons to become optically thin. This behaviour places the onset of knot emission within light weeks of the engine and ties radio changes to X-ray variations without requiring exact simultaneity. Uncertainties in the inner state remain where resolution limits apply. The precise spin of the black hole is not measured. The fraction of magnetic flux accumulated near the horizon is inferred from jet power rather than seen. The detailed partition between hot and cold inflow on subparsec scales is modelled from analogue systems rather than mapped here. Even with these limits, the present configuration is constrained by the consistent set of outer consequences, repeated cavities of measured energy and age, ripples with spacing that matches those ages, a ring that forms stars steadily and shows compression near recent rims,
The black hole's
and giant
gravity
lobes that
writes
integrate
in
multiple
invisible ink,
episodes into
and
wide
the
buoyant
stars
volumes.
obey the
Within those
sentences.
constraints, the inner state remains a compact engine that works mostly through mechanical channels, a clumpy and thick circumnuclear flow that smooths supply, and a layered atmosphere that conducts small pushes into broad, gentle heating. 3 quiet observations hold. Only modest radiative output accompanies mechanical work sufficient to fill and refill cavities over many cycles, yet the balance with cooling
How
persists.
X-ray brightness
Only small
records
bends in the
cluster's
jet
subtle
mark
acts of
passages through
heating
dense
and
gas,
motion.
yet the flow stays collimated enough to reach kiloparsec scales repeatedly. Only slow precession of axes is needed to spread energy across angles, yet the inner atmosphere remains stratified and the ring continues on its own clock. The present inner state is thus defined by order within variation, a stable stack of phases, a jet that brightens at fixed sites while the base flickers, and a reservoir that both feeds the centre and makes stars without exhausting itself. The view remains at the boundary of direct sight. It does not
Earth
cross the
breathes
horizon
in
or sum
strata,
the history
decay.
beyond the evidence written in
Weather
waves, rims
becomes
and
climate.
rings. It
Climate
stops with what can
becomes
be
stone.
seen and inferred, now a nucleus that varies quickly,
The Milky
and works
Way
slowly, a jet
bends
that turns the work
gently
into
at its
structure, a
rim.
disk that carries gas inward in a warped plane, and an atmosphere that answers with small repeated changes that keep the core bright, layered and held. Night extends across the southern sky.
Endurance in this
Centaurus
galaxy means learning how to
holds its
fade
place with quiet
without
certainty,
vanishing.
a dark lane laid across a wide, pale glow, a faint jet threading outward into the group medium. The larger structures shift on slow clocks that barely move. The smaller signals flicker and fade, leaving only a soft remainder in the air of space. Pressure keeps its gentle slope. Entropy stays layered. Waves travel and become warmth that cannot be seen, only implied by the way gradients remain where they have
A
been for a long
universe
time.
measured
The halo is still.
in soft
Shells keep their arcs. The warped ring turns without hurry and
Cavities
carries
in
young
the glow.
clusters along paths that
light. The
close only
mysterious
after many
hollows in the
crossings.
cluster's X-ray
Filaments
brightness.
of cold gas lie in the dust and wait for the next mild compression. The hot atmosphere holds a memory of crests that pass and vanish into the background. Cavities drift and soften. Their rims sink into the same sea that once outlined them. Farther out, the giant lobes rest against the group medium and continue to glow with long-lived particles and ordered fields, their edges smoothed by time. Closer in, the nucleus dims to a steady ember. Clouds in the circumnuclear screens slide along their orbits and let a little more or a little less light through without changing the larger balance. The jet keeps its narrow line and its small bends and then dissolves into the inner lobes, leaving a fine pattern of polarized skins and warm shells. The ring maintains its slow work of turning gas into stars in measured portions, neither rushed nor stalled. Silence spreads. The map of the galaxy
Heat
becomes
that
a calm
refuses to
diagram of
cool.
layers that support
Why
one
the
another
cluster's
without
gas
strain.
remains hot,
Nothing
even as it
demands
radiates
attention.
its energy
Everything
into
holds
space.
together with the patience of long time scales. The scene rests in place, bright enough to trace, quiet enough to sleep beside,